to day 2 of the MariaDB Server Fest in Beijing and Singapore. So today we start by Peter Zaitsev comparing MySQL 8 with MariaDB Server 10.5. Then we have 2 yellow presentations related to the usage of MariaDB. First, Pickup Lee, avoiding replication delays. After Pickup, we have Robert Hedgepeth from the MariaDB Corporation talking about MariaDB SkySQL, next generation database as a service from the source. Then we go to a blue presentation by Federico Razzoli, playing with the Connect storage engine, a blue feature presentation. Then we have an exciting chat, Ask Me Anything, with Monty. I'm chatting with him and people have supplied any kinds of questions to him and he will give spontaneous answers to them. After Monty, we have 2 presentations by Seppo Jaakola on MariaDB Galera cluster. The first one is a general introduction to it for those of you who haven't used it before, and the second one is looking at the specific situation we have right now, Galera clustering in MariaDB 10.5 and beyond. After that, it's Peng Fei Ma, MariaDB database clusters on Kubernetes. And then a look forward on MariaDB 10.5 and beyond by Sergei Golubchik. And today, the second day, is concluded by Sanya Alexander Bielkin, how to get your bug fixed fast by making it easy to reproduce, by showing exactly what it is that the bug is about. So let's now get going with day 2. Now for a comparison between MySQL 8 and MariaDB 10.5 by Peter Zaitsev.
Hello everyone! Today I'm going to talk to you about MySQL 8 and its difference from MariaDB 10.5, the comparison between 2 wonderful databases. I have relatively little time for this presentation, so it will be mostly high-level comparison. Now, the first thing, which I think many of you are aware about, is what MariaDB is not MySQL. And while MariaDB started from the same roots as MySQL, and the first versions of MariaDB were very similar, right now they have diverged substantially, and I would rather see them as 2 great but also quite different databases. You can still run some applications on both MySQL and MariaDB, but especially if you are using the new features introduced in those databases, then portability between them may be harder. Now, me, being the CEO of Percona, which produces a product which can be seen as a competitor to both those products, it would be hard to claim absolute fairness, so I will pledge fairness of being offensive enough to both of those technologies, and you folks probably will disagree with plenty of stuff I will say here, wherever you are MariaDB users or MySQL users. So let's dive right in, as we don't have a lot of time to spend. First, let's look at the development model. If you look at the MySQL, it is developed by MySQL team at Oracle Corporation. Contributions are accepted. Even from us at Percona, we have contributed a fair amount of small patches, though we're not the biggest third-party contributor. All right, but while contributors are accepted, the MySQL practice what I would call the dropship open source model. That means the development is not done in public, but when Oracle chose to do release, the source code appears on GitHub as well. With MariaDB, the MariaDB Server is released by MariaDB Foundation, but I would say what development and roadmap are mostly driven by MariaDB Corporation at this point. Contributions with MariaDB are not only accepted, but they are also encouraged, and development is done much more in the public, especially when it comes to the server side. What is interesting though in the MariaDB case, there are those two entities, MariaDB Corporation and MariaDB Foundation, and I, as an outsider, find this relationship to be super unclear and complicated. For example, MariaDB Foundation is responsible for MariaDB Server, but many other connectors, which you would argue are also necessary parts of the complete solutions, are owned by MariaDB Corporation and released under a variety of licenses. Now, even what you would consider Docker server parts, such as MariaDB Docker builds, are provided by MariaDB Corporation. Now, there are also other bits and pieces which I find interesting. For example, MariaDB knowledge base, which a lot of community contributes to, is hosted and controlled by MariaDB Corporation, even though you would potentially see that as a community project. Now, I also found this interesting experience just a few days ago. If you download something from mariadb.org, you would, after download completes, redirect it to a MariaDB Corporation page, which is, as you can see here, is a form which shows what you are providing the data to MariaDB Corporation, and may choose to share that with MariaDB Foundation as well, while that is not what I would expect as a user, right? If I download something from MariaDB Foundation, I would expect that is where my data would go, and not to MariaDB Corporation, which may use that for a different purposes. The next step, or next question, is what is really open source and what is not in those in MariaDB and MySQL ecosystems. MySQL follows a very clear and simple open core model. So if you think about a MySQL platform, there is a community version of a whole platform, like for example, MySQL in a DB cluster is the high availability solution, which is completely open source, includes open source router, and so on and so forth. And then there is an enterprise version, which is a commercially licensed tools and plugins, which are more powerful, of course, right? For example, you would get MySQL Enterprise Monitor, right, with a variety of graphical user interface tools only in enterprise. What also I think MySQL has done very well through history is there have been no components which initially came as an open source and then were relicensed under proprietary license as a community got some traction. In MariaDB space, MariaDB Server is open source and MariaDB connectors are open source, but there are also parts of solutions which are not. For example, if you are building high availability environment with MariaDB, the default and recommended choice is to use max scale as a router, which is not open source, it's business source license. And also the story with max scale is complicated because it was started as an open source project, but then later moved to the proprietary license as it got some adoption, which some people may consider as a form of bait and switch. MariaDB Enterprise Server is also an interesting kind of open source, right? Obviously, MariaDB inherits a lot of a GPL code from MySQL, so we can't really close source the servers. But what they can choose is to distribute the MariaDB Enterprise source and binaries only to customers, and that is what I mean by open source for customers. You can also see expand storage engine, which is something which came through Clustering acquisition, is only available in that proprietary version of Maria Enterprise Server, at least at this point. Now let's look at also about the relationship between the open source and the subscription version. In MySQL, the MySQL Enterprise is superset of MySQL Community. So wherever you use in MySQL Community will work in MySQL Enterprise and some more. There is also aligned release schedule. That means that the MySQL Enterprise of certain minor version and community, they release at the same day. In MariaDB case, MariaDB Enterprise Server is extended subset of community. It includes some additional features like expand storage engine, right? But there are also some features which are available in community version which may not be considered mature enough or not included in the enterprise or MariaDB enterprise platform for one reason or another, right? And also MariaDB platform has its separate life cycle. If you think about the cloud native, right, and I mean by cloud native in this case the Kubernetes focused, here is a situation I think is very interesting for both the database technologies, and I am not using interesting as a complement in this case. If you look at the MySQL, there is an alpha version of open source MySQL Kubernetes operator, which had last commit about 16 months ago, so it's kind of slightly dead. There are a lot of third-party Kubernetes operators and Helm charts, right, other packages available for MySQL from Presslabs, Percona, and a whole bunch of other third parties. With MariaDB, the Kubernetes operator was actually announced as one of the launch operators during the Operator Hub launch by Red Hat. But since that, it was pulled, and if you find that page in archive, a press release or Operator Hub, you will get links not found, or I'm not sure what the exact story behind that. At the same time, there is a commercial MariaDB Enterprise operator available from MariaDB Corporation, right? So this is kind of puzzling to me, because if MariaDB Foundation focuses on the service side and the Kubernetes is really one of the modern ways how you distribute and consume software, I would expect that, as long as the Docker builds, to be on the roadmap for MariaDB Foundation to cover. And of course, for MariaDB, there is a very large amount of third-party Helm or operator projects exist, right? But that is just so foundational piece of infrastructure. If you would use that, you would really want something which is well supported. Database as a service. In this case, we have MariaDB and MySQL conversion community versions are available on a variety of clouds: Google, Amazon, Azure, DigitalOcean, and others. Right? And also MySQL serves as a base for Amazon Aurora, which I would call the most popular cloud fork, right? Which is something cloud vendor forked and didn't release changes. Now, both MariaDB Corporation and Oracle, they offer database as a service for their respectful enterprise versions, right? Which are not available on the other cloud, with exception of, as far as I could find, Alibaba, which also offers enterprise version of MariaDB through partnerships. Both MariaDB and Oracle's MySQL recognize that the analytics is an important part of a modern workloads, and column store engine, which first appeared in MariaDB platform, now is available in MariaDB 10.5, like as a completely open source solutions, while MySQL has MySQL Analytics service, which is available in Oracle Cloud only. As far as I have seen, it's not have been available either in community or an open source edition so far. So where do we see the focus? If you think about MariaDB, it's initially competed with MySQL on features, getting features out there faster, right, and so on and so forth. But then MySQL was catching up with those, and I see in recent years a lot of shift happened. We focus on comparability and migration features from Oracle, Microsoft, SQL servers. Really a lot of usability for sysadmin DBAs, like for example startup scripts or like shell highlights and so on and so forth are very good in MariaDB. And more recently I see that as a cloud integration and general cloud integration, such as support for S3 storage engine in MariaDB 10.5. MySQL focus more on the traditional MySQL use cases, trying to make MySQL better MySQL. It also worked on improving SQL support, CTEs, windowing functions, like some of the things which appeared in the new releases, as well as trying to tackle the NoSQL market with doc store and very advanced JSON features. Right? We really also focus on usability for developers. For example, MySQL shell, which includes integration with JavaScript or Python. And with a cloud focus, MySQL focuses on the database which can run best in Oracle Cloud rather than general clouds. Also, other clouds, of course, benefit from a lot of features being added to support Oracle Cloud, but that is less priority. And we see MySQL is not focused on advanced Oracle features, right? And there is different theories I have heard about that. Some of them I saw is because the customers, what Oracle has, they're not asking for those advanced Oracle features because they already have Oracle for that, or maybe that is a product strategy not to disrupt or big Oracle database, right, with MySQL. You can make your own mind here. If you think from an architecture approach, MySQL really started in the recent version painful refactoring on an old code base. We can see in the DB data dictionary problem was tackled in MySQL 8. They introduced Vulkan optimizer. There is a really focus, I think, on prioritizing ease of use and limit choices, saying, hey, you know what, we're not going to really have a lot of storage engines for everything. Let's not have users think about that. We'll just have one default InnoDB storage engine. We'll try to make work for from everything. But at the same time, I think some decisions MySQL took were kind of needlessly complex and sometimes disconnected from reality, right? For example, MySQL GTIDs introduction in the time was, well, quite fiasco. Right. For MariaDB is more focused on pushing old code base further. Right? It didn't have such a massive change as MySQL took in MySQL version, but really it prioritizes a lot of choice and flexibility, support for multiple storage engine, right? And really its development team, I think, is working much closer with the customers and much closer to understanding the practical operations problems sysadmins, right, and otherwise would have. Now, in the recent years, MariaDB also acquired some InnoDB developers, and it has its own philosophy and roadmap on making InnoDB better. And now I think you have a very fun opportunity to compare the Oracle's InnoDB to MySQL's InnoDB to see which one performs well. And I think that is fantastic competition, which we will probably benefit users overall. Here is example of release frequency. If you can see what MariaDB releases much faster than MySQL. If you see in this case, MySQL has a major release every 2-3 years, right? Then we don't know when and if next MySQL major release is coming. MariaDB has been working last 4 years, almost like a clockwork, releasing the new stable release sometime in May or June every year, right? So very different life cycle. Though that doesn't mean that the MySQL is moving very slow. The release philosophy is also very different. MariaDB continues classic MySQL philosophy, where you have relatively frequent major releases, and then there are no major changes in minor releases. So that's kind of mostly bug fixes and small tinkering, right? And that also means that you can do both upgrades and downgrades, keeping dataset intact. The MySQL 8 is what is called evergreen release, right? It's saying, hey, you know what? We are breaking that old ideas. Now we're going to introduce features in minor releases. And what that also means, you won't be able to do downgrades. Okay. With that, let's look at some more technical specifics. What do we have in terms of client protocol? Both MariaDB and MySQL support classic MySQL protocol, but also MySQL has done some extensions. For example, it supports SRVD next record support, and I think the biggest new thing in MySQL is this thing called X protocol, which allows you to the new protocol, which you can use both SQL as well as a doc store protocol. In MariaDB, it has classic MySQL protocol as well as its own protocol extensions, for example, for progress reporting and some others. If you look at the interface support, MySQL, you can use classical SQL, you can use doc store, you can also use Memcache, talk to that through Memcache protocol. MariaDB supports SQL as well as handler socket plugin. If you look at JSON support, that is, I think, where MySQL is substantially ahead. It has a native JSON data types. It supports very efficient partial updates of large JSON fields. It has things like JSON shortcuts, which you can use conveniently inside of queries. Advanced features such as JSON tables. Where with MariaDB it has some JSON functions, but it also stores JSON as a text field, and there is, I think, a lot of work is being done in MariaDB right now to support JSON better. Replication. In MySQL, you have MySQL group replication and MySQL's GTID. Now it has added also a clone plugin for efficient provisioning, which can be used for both classical MySQL replication as well as a group replication. MariaDB does not support group replication. It uses Galera replication instead, and it uses also its own GTID, right? So replication is something which is a very different between those two databases, and in generally ways how you provide availability, right? So that is something I would be looking very closely to. In terms of SQL standards and compatibility, I cannot find anything big which MySQL has which MariaDB does not offer, right? So I think MariaDB, well, outside of JSON, right, frankly. MariaDB, though, it adds SQL mode equals Oracle, which has a lot of Oracle-like extensions. It supports system version tables, sequence. It supports packages and storage procedures, right? So a lot of stuff to compatibility with standard and with other databases. Now, if you want to look into the more detailed feature comparisons, you can check out these fantastic blogs on modernsql.com. Though I would point out they are both now about 2 years old. It only covers MariaDB 10.3, and MariaDB 10.4 and 10.5 have more stuff. And also, actually, MySQL have been adding more features in the new MySQL 8 releases, right? So be careful with that. Security. there are significant difference in security and user account management. You know, how roles are implemented, privileges, the names, what corresponds to, right? So that is also something there are a lot of difference, right, if you're considering migrating between those technologies. Optimizer is another huge item which their database are very different. Right, I would see if you are moving some complicated queries between MySQL and MariaDB and vice versa. We really check out Explain for them, because performance for complicated queries can be substantially different. Right, and if you talk to both development team, MySQL and MariaDB folks, they both can point to queries which run better, faster on their platform, right? But in the end, what you probably should know as a user, hey, there may be difference here, be careful with that. Well, and in fact, that is all I have. If you're interested to hear some more about the open source databases, including MySQL and MariaDB, I want to invite you to PyRCon Live Online in October 2020. With that, thank you. Let's keep in touch.
Now we will be talking about avoiding replication delays. So pick up Lee. Here you go.
Hello everyone, I'm Pickup Lee, the Chief Architecture of Virtual Technology. I'm currently responsible for the department of MariaDB kernel. Virtual Technology is a database ecological product company focused on the field of private cloud, providing enterprise users with high performance, high availability, and scalable open database cloud platform solutions. We encounter some replication delay issue when help our customer to solve database problem. I believe this experience will be useful to people like you who are using MariaDB in product environment. So let's begin the discussion on this topic. You can see the replication structure of MariaDB on the right of the slide. MariaDB write event to binary log when user commit a query on must. Slave use else read to read the bin log from must and write to the local relay log. The circus read on the slave gets the event from the relay log to replay queries from must, ensuring that the queries on the slave is the same with the queries issued on the must. On the slave, you can check the replication delay through show slave status, which you can see on the left of the slide. The value of second behind must represents the delay of replication. As you can see, the second behind must here is very large, which is 1,800 seconds. Let's look at the scenario on the slide. It's a read-write separate infrastructure. Application write on the must and read from the slave. If the replication delay second is 1,800, the data read by application from the slave will be half an hour ago. It's unacceptable. And this is another scenario for database administrator. Application read and write and must. But the slave lag behind the must for 1,800 seconds. If the must get done at this time, the application must be fed over to read and write data on slave, which means over 1,800 second data lose totally. So it is very important to avoid replication delay and ensuring that the data of slave and must are consistent. To solve the problem of replication delay, we need to know the method how to get replication delay. Let's take second behind master for example. Second behind master equals to clock of slave minus last timestamp executed by circus read minus clock diff read must. Clock of slave is current timestamp of slave. Use time 0 of C language to get it. Last timestamp executed by circus read is timestamp of last event executed by circus read. The clock diff read must is the difference between current timestamp on the slave and the timestamp of select now on the must. It is calculated only once when else read is started. As you can see, second behind must is not reliable. For example, if the system time change on the slave, the second behind must is not exactly replication delay because the clock diff must does not recalculate before else read be started. And if the else read and or circus read is corrupted, you cannot get value because the second behind must is set to null. Someone has listed the drawback when using second behind must to monitor my circle replication delay using Prometheus. Please take a look at the snap. Of course, second behind must is not the only one method to get a replication delay between master and the slave. We can also use PT heartbeat to get the replication delay. It updates a record in the must every 3 seconds, and then get the delay as now minus timestamp of the record on the slave. You can update heartbeat table on the must and use monitor and check to get the delay of the slave on the slave. This is a general method which is more scalable for getting delay of replication. PT heartbeat support post-grid circle and even work when else read or circus read is corrupted. So as you can see, if we want to solve the problem of replication delay, we must let the circus read always catch up with the must. So how to avoid replication delay? Firstly, we should care about the server config of the slave. The configuration of the slave should be similar to that of the master, especially the memory and the disk. For example, the master is SSD, solid state driver on an exclusive database server. The slave is HDD, hard disk driver on a virtual machine. You can see the difference of LPS on HDD and SSD on the upper right column. The slave should be much slower than the master. You certainly cannot expect the slave to catch up with the master. If the memory of the slave is much slower than the master, the power of InnoDB may not enough to hold the cache data, which will also increase the replication delay. Parameters set to MariaDB may also increase the replication delay. Let's look at this parameter in the slide. If the parameter of sync master info, sync relay log info, and sync relay log are set to 1. Every time the I/O thread pull a event from the master, it needs to sync the relay log and the master info file. Every time the circle thread executes a circle statement on the slave, it should also need to sync the relay log info. It requires more I/O resource on the slave and will increase replication delay. So if the disk has a catch back by battery, consider setting sync master info at 10,000, sync relay log info at 10,000, sync relay log at 10,000, and set relay log recovery as on. Let's look at parallelized replication. Before 5.5, MariaDB only have one circle thread on the slave to apply circle statement. That means that the transaction execute one by one on the slave. If there are more queries issued to the master, the slave will fall behind. The replication delay increased. To solve the problem, we have no choice, but only help our customer to upgrade MariaDB to the version of 10.0 or even higher. In the version of 10.0.5, MariaDB provides an awesome algorithm to increase replication performance. It applies multi-transaction in parallel using a pool of separate replication work threads. On the master, if two transactions commit together in a group, they are writing into the bin log with the same commit ID. Such events are certainly to not conflict with each other, and they can be scheduled by the parallel replication to run in different work threads. Database administrator can set the number of slave parallel threads to identify how many concurrent work threads to apply the binlog event upload from the master. And slave parallel thread is a dynamic variable that can be changed without restart MySQL. In addition, begin with 10.1.3, MariaDB added a consequence mode of slave parallel mode called optimistic, which provides a lot of opportunity for parallel apply on the slave. But it still preserves exact transaction orders from the point of view of application. And now it is the default model from MariaDB 10.5.1. As a optimistic algorithm, it applies transactions in parallel as many as possible. If two transactions try to modify the same law, any such conflict is detected, and the late of two transactions is rolled back, allowing the former to proceed. The late transaction is then retried once the former has completed. The term optimistic is used for this model because the server optimistically assumes that the few conflicts will occur. So there are rarely few actual work spent on rolling back and retrying complex transactions. But the gain from running most transactions in parallel is great. By the way, you should pay attention to MySQL in replication. MySQL does not support transaction. It just provides table-level locking, so you may get large replication delay when using MySQL table, even using the version higher than 10.0. Parallel replication of MariaDB cannot completely solve the problem of replication delay. Let's take a look at this scenario. A transaction in the transaction group submits a long query to the master, such as delete 100,000 records from the table of order. This transaction executes more than 3 minutes on the master, and will last for more than 3 minutes on the slave. Other transactions will behind the group of transactions cannot start to execute before this transaction finishes. The long-run query increases replication delay, but there are many solutions for it. We can change the application to delete only 1,000 rows in a transaction and loop for 100 times. This solution will reduce the log time on the master. Developer would love to change the application. But for DDL, it's not so simple. Suppose the scenario there is an update to item and user info commit in the master, and at the same time another DDL transaction on the table order committed. Here is the circle. All table orders, change column, order number begins unsigned, not known, auto incremental. It will change the order number from int to big int. Same as the delete long query, it will increase the replication delay. The current MariaDB solution can only assume that the DDL will not conflict with other concurrency parallel DML. So you can set GTID domain ID at the session level to allow DML and DDL to execute in parallel, like this. And a more general solution should be GHOST. It creates a ghost table like your original table, alter the ghost table as you desired. Incremental copy data from the original table to the ghost table. Any insert, delete, update applied to the original table will also apply to the ghost table. Finally, at the right time, GHOST will rename the original table with the ghost table. All of the operation on the table is quite simple and can finish only in seconds. And they will run in parallel with other queries, so it's not increase the replication delay. As a cloud service provider, we must ensure that the MariaDB we provide to the customer should be a high availability service, which means that if the master node that currently provides service to customer has gone, the slave must replace the master in time to continue to provide database service for a replication. At this time of failure, the replication delay of the database must be small enough to avoid data loss. The most difficult problem we encountered was table without any index, because binary format is set to row by default. Every insert, update, delete operation will record as change of each row in the binary. For example, the table of order has 5 million rows in it, and we want to delete order where all the data before last month. This delete query will record 5,000 rows of data delete in the binary. So there are 5,000 queries will execute on the slave. If the table of order does not have any index like this, there will be 5,004 table scans on the table of order with 5 million rows, and you may get thousands of replication seconds. As a cloud service provider, we cannot force our customer to add index to the table. So we implement a hidden index specially for such table to avoid replication delay. Firstly, when user create a new table, we will check whether the table has any index. If there are no index, we will create a new hidden column for the table and add an index of column as the red color text. The circle execution plan of full table scan will be changed. Secondly, when the user alters the table, it is necessary to check whether the modified table contains other index besides the hidden index. If the user add an index, the new hidden index needs to be cleaned up. We will change the statement like this. And this is the final table definition. Additionally, in order to prevent user from accessing the hidden column and hidden index, we need to restrict the privilege of this column during select, insert, update, delete, and show operations. For end user does not need to notice the existence of hidden column and hidden index. From the version of 10.3.3, MariaDB has provided a feature an invisible column. Here we create a table of items with an invisible column discount. The column cannot be accessed unless explicitly mention them by name. As you can see, the second insert will return error, and you will not get the column when you select star from items. But if you explicitly select the discount column from the table, you can get the value. We change the implement of this feature for hidden column. The biggest difference of hidden column from the invisible column is the privilege. User without backend privilege cannot read or access the hidden column. It will return error of unknown column, like this. Another similar feature is the invisible index introduced in the version of 8.00 of MyCircle. Here we have a table of items. If you select the information from the table of item ordered by price, it can use index condition for range index scan as circle execute plan. But if you change the index to invisible, the circle executing plan will change to full table scan. So the invisible index of MyCircle is not what we need for hidden index. The invisible index of MyCircle is not visible to the optimizer, but our hidden index needs to be visible to optimize, which only hidden to the for-end user. At the end of this topic, let me summarize the main content of this topic. We start from the MyCircle replication infrastructure and review the problem caused by replication delay and how can we get the second of replication delay. Then we go through the parallel replication improvement introduced by the version of 10.0 and 10.1 of MariaDB. After that, we try to solve the problem of replication delay caused by long query like big, delete, and DDL. Finally, I introduced the header index solution implemented by WatchTag to help the non-index table. I hope that through my 30-minute introduction, you can understand MariaDB's effect to reduce replication latency and give you some advice for reducing the delay on the replication. Finally, thank you very much for participating in this discussion of topic. And thanks very much for MariaDB Foundation for organizing of this conference. If you have any other question, please send me email at pickup.lee@watchtag.com. Thanks very much.
And now for a cloud presentation by MariaDB Corporation's Robert Hedgepeth, MariaDB's SkySQL next generation database as a service from the source.
Hello, welcome to MariaDB Server Fest. Today I'm going to be talking to you about MariaDB SkySQL, a new database as a service offering from MariaDB Corporation. And first things first, I want to introduce myself. My name is Rob Hedgepeth, and I work a part of the developer relations group at MariaDB Corporation. And essentially that means I do anything and everything that I can in order to take the developer's journey and experiences and make them as positive as possible when working with MariaDB. And a lot of times that involves creating content from webinars to sample code, blog post, anything and everything that I can use to really help developers of all kinds and all learning styles basically get up to speed with MariaDB. If you think at the end of this session you'd feel like providing me with some feedback, asking me any questions that you may have after this, please feel free to reach out to me. It's my email, robh@mariadb.com. You can follow me on Twitter or message me on Twitter at probablyrealrob. And if you feel so inclined after seeing some of my code, want to either judge me or follow me, you can find me on GitHub at rhedgepeth. All right, so let's go ahead and jump into this. As I mentioned, we're going to be talking about MariaDB SkySQL, and we're going to take a look first at some of the slides and dive in really to, from a high level, the architecture of how SkySQL was created and planning on being used across multiple different cloud vendors in the future. And then we're going to take a look at some of the capabilities that are provided in SkySQL, and this really helps us set up the foundation that we can use then to jump into some sample code and start looking at demonstrations of not only connecting to and getting started really using SkySQL, but specifically looking at HTAP, or what's known as hybrid transactional analytical processing. And from there, we'll take a look at a third-party integration tool known as Jupyter. It's a notebook application, and we'll see what we can do from an analytics standpoint or a data science standpoint with some large data sets that we're going to be working with. But let's go ahead first and start by diving into MariaDB SkySQL. Well, first things first, of course, is we need to understand what SkySQL is. As I mentioned and said in the title, it is a database as a service. Now, you probably know what a database is, right? Well, if you're at Serverfest, you most likely know what a database is, right? Because you're such a fan of MariaDB, which is awesome. And you can think of a database really as the simplest sense of, a bucket essentially holding something, right? And essentially that something is then persisted, right? So you've got this persistent data storage, and that is the simplest sense of what a database is. Now, this cloud in the background essentially represents a DBAS, right? Or a database as a service. And its job really is to provide a layer of abstraction for the database itself. So being able to allow users to use the database without having to worry about things like provisioning machines, installing or maintaining and updating the database, and a variety of other things that goes along with having to install and ultimately maintain a database long term. And obviously, if that's a database as a service, then if MariaDB SkySQL is a database as a service, then essentially this bucket, we can just give it the logo of MariaDB, right? And that's ultimately what SkySQL is, right? But you may be wondering, what's really the difference between SkySQL and Azure databases and Amazon RDS, right? All of those things have MariaDB or flavors of MariaDB. And the main difference from the highest level really is that MariaDB SkySQL runs using enterprise server bits, and RDS and Azure databases run using the community service bits. Now, there's pros and cons, of course, to using community versions and to enterprise versions, and I'm certainly not here to market or sell any of that. But ultimately, that's what the difference is. And we'll see a couple of different ways, especially within the architecture that it's set up, in order to just differentiate really SkySQL from some of the other options that you have out there. And that really starts first with the architecture. If we're taking the highest level view, we're going to look at some of the options or some of the technologies that we used in order to be able to create SkySQL. And you can't get very far into an architecture discussion about SkySQL without mentioning Kubernetes. For those of you who may not be aware, there are these things called containers. And containers can contain any number of things from a technology perspective, but the idea is that they're self-contained, portable, and something that is very popular today, right? And in this instance, we're able to use database instances inside of containers. Well, Kubernetes is a way that you can actually orchestrate or manage those containers. Now, we won't get into the minutiae really of things like Kubernetes pods, nodes, and clusters, and talking about the intricacies of that, but essentially we're using Kubernetes, which then helps maintain a level of high availability, among other things, along with MariaDB SkySQL or MariaDB database instances. And so the combination of these two really provide a very robust and modern approach to being able to create what is the groundwork for database as a service. Now, Kubernetes also has an API which we take advantage of so that we can use cross-cloud service providers, right? So if you think of Azure, you think of Google Cloud, and you think of AWS, we're able to use our Kubernetes approach across different cloud vendors. And that really allows it to scale. Now, on the other side, or the other end, we have a front end, and that is powered by something called ServiceNow. Now, it's not necessarily important that we dive into what exactly ServiceNow provides or offers, but essentially what we're using it for is the ability to both configure and manage the inventory and the workflow of the MariaDB instances underneath the hood. And we've peppered in some very awesome kind of modern technologies, open source technologies in Prometheus to handle event monitoring, and Grafana for some visualization, as we'll look at some real-time monitoring of the database that we can do using those tools through SkySQL. From a separation of concerns or a more modular aspect, we use a portal or a front-end portion. We have what's called a control plane, which we'll dive into a little bit after these bullet points into more of an image view or an architecture slide view, which then helps us communicate with the database or underlying databases that live within the Kubernetes cluster. And all this is really done to provide a high level of compartmentalization, of course, with the modularization, isolation, and ultimately a way that we can control indirect access, right? Even with ourselves, of being able to access the databases that live within SkySQL. Now, here is a high-level view of what SkySQL looks like from a user's perspective, right? If you start from the left-hand side, you can see that what we call customer admins or users, right, log into a web UI that allows them then to be able to control the workflows and the inventory, right, of the databases that, if you look on the very right-hand side, live within the Kubernetes cluster. Now, there is some layers in between there, and that's that control plane that I mentioned before. And its job really is to, of course, relay from left to right, we see here, relay the tasks that are created through any kind of inventory or workflow management into the control plane, which then is going to translate that information into commands to send to the Kubernetes cluster on the very right-hand side. And from there, we can gather everything from, of course, database results, metrics that we can use and flow back into the UI and visualize using those open source tools that I mentioned before. But most importantly is the ability to provide indirect access for our Sky DBAs. Now, I'll dive into a little bit more of what it means, the term of Sky DBA, but essentially you can think of it as a MariaDB professional database administrator, right? And they're going to log in using an identity proxy and through a jump server to gain access to the database instances that live within those clusters. From there, they're able to perform a lot of the roles that you would imagine DBAs can, but again, from indirect access, never having direct access to the database itself. Now, from a customer side, you can access the database through a firewall, which we'll dive into as we get into the demonstration a little bit later on, through your applications and third-party clients, and even the MariaDB client, as we'll see a little bit later on, to actually access the database. But that's the overall gist. Now, obviously, all of these things are cross-cloud service provider, as you see at the very top here. So the intention is that this would work exactly the same for AWS, Azure, and Google Cloud. You would just be picking a cloud service provider ultimately whenever you want to use SkySQL. Now, on the other side of that, we have our services that define more of what's available from the actual database as a service part, right? To show what's available from the service of SkySQL. And that really starts from a topology. When we think about how we write code or how we may write applications, a lot of times you don't necessarily have to use the same kind of environment for your production servers as you would for your development or your test servers, right? And so we have different topologies to accommodate this. And on the left-hand side, you'll see that we have a standalone instance. And that standalone instance provides us with the ability to create maybe a test or a development environment. And it's going to come with a variety of functionality that, of course, are available within a multi-node setup. But some of those include transactional, more traditional row-based databases that you can spin up services for if you think of like InnoDB. Analytical services, so if you think of column store, if you're familiar, which we'll get into a little bit more of the details, or even a combination of the two where you can actually combine both transactional and analytical storage on the same server and then even run single queries against those using HTAP, as I mentioned before. And this all is kind of rolled up and available to be able to have real-time monitor against it as well. Obviously, you're going to want some form of configuration because, as we know, MariaDB has a pretty robust collection of system variables and configuration parameters, essentially, that you can set in order to make it tuned and run really well for your workload. We wanted that to be available, of course, within SkySQL and highly customizable, as we'll see once we get into the demonstration. With any professional database, of course, there needs to be disaster recovery and automatic backups, which happen nightly. Point-in-time restoration, of course, if you needed to go back in time to restore your database at a certain point. And as I mentioned before with Kubernetes, there is the ability to provide this high availability through something called self-healing. Essentially, when a Kubernetes pod were to die or go down for a variety of reasons, then it would self-heal itself so that pod would spin back up and be able to be very resilient that way. On the other side, or on the right-hand side here, we see a more multi-node setup where you'd think of a production environment. And in cases like this, you can use something that's in tech preview now through our expand product, which is called distributed SQL. And distributed SQL is basically being able to take database and spread the information out using this thing called a slice or slices onto the machine or the nodes for massive amounts of information, right? So we're talking billions, tens of billions of records being distributed throughout these nodes. And we'll see that as an option as we dive into the SkySQL portal a little bit later on. Of course, even more high availability, right? So as you create more nodes and you have these primary replicas, you have, inherent advantages, right, from the cloud service providers through multi-node deployments and replication. There is a product in MariaDB called MaxScale, which you've probably heard of, which is simply just a database proxy. Not simply, it is at the highest level of database proxy. And of course, that provides all kinds of capabilities like automatic failover, transparent query routing, read-write splitting, and a variety of other features, which it's good to know about, but we're not going to dive into as in depth with this particular session. And lastly, before I jump into the demonstration, I want to talk a little bit about SkyDBA, as it is a distinguishing factor about MariaDB SkySQL. Essentially, as I mentioned before, you get the MariaDB professional database administrators, which provide everything from consulting types of support, which include health checks, performance analysis, and security audits. But the main takeaway here is that when you think about a database administrator, it's very rare that you get a situation where the actual professionals, so the company and the group that built the database, provides database administrators as a service, right? And you may find that in, if you think of other, cloud databases like Mongo, right? Mongo's Atlas. You may find it in situations like that, but it tends to be a very sought after type of service because it's rare that you would find that professional that works for the source that's actually building the database as well. Okay, and that brings us to our demonstration. So what we're going to do first is we're going to dive into the portal of MariaDB SkySQL, and I'm going to take you through a tour where I'm going to show how you would look first at launching a service, a database service that you can use, and what all is really entailed in setting up that service and how easy it is to get done. But beyond that, we're going to take a look at some of the other features that start to distinguish SkySQL from other databases as a service that exist out there. And then that's not to say, from a sales perspective, but really just this exists here, and this is why we think it's important type of perspective. And then we're going to take a look at a sample where we build two databases, and in those two databases, we're going to provide two different types of tables, right? Where we're going to be looking at NODB tables, and we're going to be looking at column store tables to combine into an HTAP instance that we can use to show off the power of HTAP within MariaDB SkySQL. So let's go ahead and flip over to SkySQL. All right, so this is the portal, again, powered by ServiceNow for MariaDB SkySQL. You can reach it by going to cloud.mariadb.com/SkySQL. And when you do, you're first going to be asked to actually launch a service. So the screen is going to look very similar to this, where it's going to ask you to launch a service. And you've got a couple of different options here. On the very left-hand side, you've got the simplest example of a transactional-based system, right? Where you're using row-based data storage that stores the information in persistent block storage. Next to that, you have something called analytics. And analytics is simply looking or storing analytical information that exists in MariaDB column store. So a columnar database, which is different, of course, than a row-based database, but is really more for looking at large amounts of information without indexes in more of an ad hoc fashion. And there's a couple advantages to being able to use columnar storage, obviously beyond the performance implications that you get. It's also stored within low-cost object storage for each of the cloud providers. So it's a little bit different than the way you would store transactional information in persistent block storage. You're actually able to store this in object storage. And then on the very right-hand side, you can see that we have this both option, and in parentheses it says HTAP, and that stands for Hybrid Transactional Analytical Processing. And that essentially is the combination of transactions on the very left-hand side and analytics in the middle portion here, and being able to combine both row-based and column-based data storage mechanisms in a single query, which we'll certainly get into. And lastly, something that I'll mention, but we won't really get into too much, is the option at the bottom, which is still in tech preview, but it's something called scale out transactions. And I briefly mentioned it before, but this is this idea of distributed SQL, where you're able to split large amounts of information over multiple nodes and be able to still have a very low latency and high availability available to you within the service itself. So if now we want to go ahead and launch a service, let's go ahead and start by looking at transactions. So I'll click launch, and it's going to, of course, give me a description of what transactions is in the form of MariaDB platform and MariaDB SkySQL. But the first thing that we're going to see is that we have a topology which allows us to pick either a standalone instance or a primary replica setup, or that multi-node instance that I had mentioned before. Now, for this demonstration, we're just going to go ahead and stick with standalone, as we're just using this to basically develop on or to test some of these integrations with. Next, you'll be prompted to pick a region. And we've got, as you can see, 3 regions within the US, 1 in Asia, and we have 2 regions within Europe. After that, you're going to hit probably the most important part of this selection process, which is looking at the resources that you want to use for your database instance. And that's going to be based on 2 things, right? You're going to have the amount of CPUs, or virtual CPUs and cores in this case, and the amount of memory that you want to use. And it ranges from everything from 4 CPUs by 15 gigs all the way up to 64 by 416. And on the right-hand side here, you can see probably the most important part of this table is the price. And it gets drastically more expensive, of course, the larger the machine gets. Next, you'll want to take a look at the amount of transactional storage that you want to have. And this depends, right? So if you're a transactional database service instance, and that's solely what you do, it may be that you want more. If you have analytical and you need some kind of persistence disk storage of some sort, you may pick less. But it ranges from 100 gigs all the way up to 6 terabytes. And of course, has a factor on cost as well. From there, you'll want to pick the MariaDB MariaDB Server version. And right now, there's currently 2 versions of 10.4 and 10.5. Because MariaDB was released back in March, and the summer release for 10.5 happened just a little over a month ago. Then you simply pick a service name and click Launch Service. And for the sake of time, in the instance of saving time for the demonstration, I've gone ahead and created some services. So I'm going to go ahead and click Your Services on the left-hand nav, and I'm going to leave this set up because I've actually created an instance that's exactly the same that we're going to use for an example going forward. Now, when you see this, you have a table. Mine just has 1 entry in it. But this table contains a lot of the same information we just looked at whenever we were launching our service. And really, the only thing that really stands out here is a little bit different are the health check in states. And it's simply just telling you what the service is doing right now. And right now, of course, we can see that it's healthy. So we can click on this row and go into the instance itself for more details. Of course, it's going to give us the name of the instance, some versioning information, and then the configuration that we chose. But what's new to us here is that in order to be able to connect to a database instance, we need 2 things. We need a fully qualified domain name, which we see here just towards the middle, and we need a read-write port number. So we need a port to actually access the database instance on. Beyond that, as I mentioned before, we have the ability to add custom configuration. Now, currently, this is a fresh instance, so I haven't done that. But if I wanted to add a custom configuration, I can either click Manage Custom Configurations here, or I can look at the left-hand navigation and I can say Configuration Manager. And I point this out, really, so that, 1, we can see all the configuration options that are available, at least from a brief glance, but also to note that there are already some defaults that come out of the box that you can choose and that you can clone, or you can create fresh configuration values altogether. For this, we're going to go ahead and take a look at what I've already created as Rob's HTAP configuration. Now, as you saw whenever you first saw, and you can see here at the title, it says Rob's HTAP config 3. if I were to minimize that, you can see that it has gone through a couple of iterations. And that's because every time you change a configuration value or some kind of variable within this configuration set, it's going to version that. And that's important because if we've got multiple database instances or multiple services out there using this configuration, we can upgrade or keep the same just depending on how we want to use this configuration setup. And as you look inside of this table, you can see all kinds of configuration values. Now, they all have a default setting, but if you want, right, you can scroll to the top here and you can click Actions and Edit Configuration. This allows you, through a series of drop-downs, to go ahead and change these configuration settings. So if I go down to the bottom here for my timeout, maybe I want to decrease that 600 seconds, and I can save. And I'll see that I actually then get a version bump. So now we're at v4 and it saves the previous version history. If I navigate back to my services, back into my HTAP demo service, I'm then able to pick a configuration for my HTAP service by picking the little gear on the right-hand side, and then I can choose a custom configuration, which is filtering it based on the service instance type that I'm using, which is HTAP. Can apply it, and it will apply those configuration settings. So pretty easy, but also pretty robust and configurable. Now, from an access point of view, I mentioned before this idea of a firewall. And in order to be able to access MariaDB SkySQL, you're going to have to enter either an IP address or a range of IPs. And that's going to be done by clicking this little pencil on the right-hand side and then simply entering in your IP address. Now, I've already done this for the sake of saving time, and so I'll already be able to access this service. From there, you have the ability, of course, to stop the service, delete the service, and most importantly, for being able to access this service, you want to look at Show Credentials because it's going to give you the username, the original or default password, the ability then to download what's called a certificate authority chain. It's simply a certificate that you have on the client that you then can give to the server to say, hey, I can talk to you through SSL. And then you're going to get a couple of points here which are going to remind you, hey, you've got to add your IP address to the whitelist. Here is some sample CLI you can use with the MariaDB client. And you probably want to change your password to something that isn't as gobbledygook as what we provided, but also is a little bit better than the new pass, which you see here is the example. Now, before we jump into the integration portion of this, I want to go ahead and take a look at the left-hand navigation to point out some of the features that exist in MariaDB and the state of which they're in, but also some of the potential that some of them have. So we're going to start by taking a look at the workload analysis portion that you see here on the left-hand side. And this is still in tech preview, but as we know, workloads can be pretty complex, right? It's not as easy as write first or write only, a read-write based workload. Oftentimes, your workload can change drastically on weekends, on nights, on holidays. And so we've combined some machine learning models with the data that you start to accumulate in your databases really to understand and be able to optimize the workloads that exist within the databases that are used within SkySQL. And so this is something that's still in development, so I heavily suggest at least reading about it. It's pretty cool from a machine learning perspective, the things that we're looking to do. Now, it's still in its infancy, so it's got a lot of work to go before we can start getting into the optimization and some of the predictive things that we'd like to do with workload analysis, but it's pretty cool. Now, beyond that or below that, we have the capability that I've brought up a couple of times, which is real-time monitoring. Using Grafana and Prometheus, then on the data that you're storing inside of the instances, we're able to do some event monitoring and look at things all the way from the CPU workload to a query analysis to just query workload in general. A lot of really cool things that we can actually look at in a real-time perspective to give you feedback on your databases and the database instances underneath. Of course, those are whitelisted as well, so you would need to add any whitelist IPs for any access that you'd want to have into monitoring or workload analysis. You have the ability to go straight into MariaDB SkySQL directly from this link, and of course you can reach out to MariaDB support if you need to. And with that, I think it's time for us to actually step into some code that we can use to see exactly how we connect to and integrate with SkySQL, but also be able to use and look at HTAP so that we can check out our second example, which is in Jupyter. All right, so let's go ahead. For this part of the demo, I'm going to be taking a look at a GitHub repository that I've already created in order to pull down and show how we can actually connect and communicate with SkySQL. And then we're going to take a look at an HTAP database to see exactly how we can use things like cross-engine query to look at both row-based information and column-based information. So I'm going to start by opening up a terminal window, and I'm going to do a little bit of a cheater here, and I'm actually going to bring in my git clone command. And actually, I'm going to go ahead and take a look at a specific folder and load my terminal window there. And here, I'm going to actually pull down my repository, clone the repository, so that we can use some of the bits inside to actually communicate with SkySQL, but also create a schema and load the information in there. So let's go ahead and pull down our repository now. All right. So now that I've pulled down the repository, you can see that I've pulled it from MariaDB Corporation GitHub account and a pretty long name here of dev example SkySQL HTAP quick start. So because that's so long, I'm going to use the CD and I'm going to paste in the name of that folder. So once I'm in that folder, I can see that I've got quite a few things between files and folders. But to give us more of a visual appeal, I'm going to actually open up an instance of Visual Studio or VS Code to go ahead and take a look. So let's go ahead and go into my server fest directory, and I'm actually going to use this entire folder. Take a look at my repository. And the first place I want to start is by taking a look at a create and load shell script. Now, I've combined everything inside of a single script, right, so that I have the ability to both display what's going on here all in a single file, but also keep the time for the demo down without me having to go back and forth and entering in commands, or even worse, probably typing those out and fat fingering everything. So as we get into this shell script, we can see that I am simply using the MariaDB client, and I'm providing it things like the qualified domain name, the port number, the username, the password, and that SkySQL chain PIM file, which is the certificate authority chain file that I can use on the client to tell the server that I can connect. So before I can use this shell script, I actually need to go back out to SkySQL, and I need to download this file. So I'll download the file. I'm going to show in Finder, and let's actually go and click back over into my Visual Studio Code. I will bring in my SkySQL chain PIM file, and I'm just going to drop that directly inside of my Explorer window. And that's because I relatively use it from this spot, right? The same spot that create and load shell script lives. From there, once I've connected, I want to go ahead and use a couple of files. So I'm going to use a SQL script idb_schema and cs_schema, and these are going to allow me to create my travel database, which contains my InnoDB tables, and my travel history database, which contains my column sort table of flights. And then I'm going to load information into these tables. So I'm going to start by loading airlines, a collection of airlines into the airlines InnoDB table using a CSV file. I'm then going to load a collection of airports into the airports table on the InnoDB side. But then I'm going to actually use a CSV to load about 700,000 records into a column store table on the travel history database. And this is going to allow me to have two different schemas with different collections of tables, but after I load that information in there, we're going to take a look at something called a cross-engine query, where I can actually combine and join tables from the InnoDB side to the column store side in a single query. So let's go ahead and load this script, or run this script. So I'm going to start by opening a terminal window. One of the reasons why I love VS Code. So I'm going to open a terminal window directly in the code editor itself. And from there, I'm going to cd, and I'm going to actually attempt my hand at actually seeding into my quick start. Hey, first try. And from there, of course, I have the ability to run the shell script. So now I'm going to cheat a little bit, and I'm actually going to paste in the command, which is essentially just running my shell script and giving it the arguments of my domain name, my port number, username, and my password. So I'm going to run this script, and it's giving me a little bit of feedback here saying that it's created the schema. I've gone ahead and I've loaded both the airlines and the airports information using a CSV. And now I've actually loaded the flights information into the flights column store table. To confirm this, I'm going to connect using the CLI quick command here of being able to use MariaDB, going to enter in the password, and now I'm actually inside of MariaDB SkySQL. And I can confirm that my script worked by typing in show databases, where I can see that I've added in travel and travel history. Now, to confirm that I've got information inside of travel and travel history, I'll first start with travel, and I'm going to use that database and just go ahead and take a look at the amount of information that's inside of my airlines table. So we've got 30 records that exist inside of my airlines table. Now, if I wanted to be able to use my information that now exists inside of my airlines table with my flights table, I'm going to be using something called a cross-engine query, right? So here I can tell that I have from travel history, since I'm in travel at this point, I can see that travel history, flights, I have about 700,000 records. So if I want to combine that, I can simply, using HTAP, I can simply write a single query, which is going to allow me to use a cross-engine query or cross-engine join around those, or using those two data storage mechanisms. So I want to type a.airline. I'm going to create an alias after this, obviously. And I want to type, I want to get something like the average delay, the average delay from flights. So the departure delay is a field that is held within the flights table. And from there, I want to actually say, I want to use travel.airlines. I'm going to give that an alias of A. I'm going to interjoin that with travel history.flights F, and I'm going to join on A dot something named as an IATA code, which is the equivalent of the carrier which exists inside of the flights table. And then from there, I want to group by my A.airline for my airline field, and then I can simply, looks like I actually have an issue. Let's see, select airline flights delay from travel airlines A from, oh, inner. I guess I need to actually join the two tables, so you can't just do inner, means nothing at all, obviously. So I can do inner join. Now, I have the information from both of those two data sets. And I can simply use any kind of, I can modify this if I wanted to order by the actual average so that I can get some a little bit easier to read information on the delay itself. Again, I am the best at leaving out words, so we actually want to order by, but then that gives me the ability to look at which actually has the best departure delay, and of course, being able to show what's a little bit more important to me, which ones have the worst, so I can avoid those particular airlines in the future from, and I could dive into different airports and where that may happen. But this allows us to look at a cross-engine query. Now, doing this through the client isn't exactly exciting. So what we can do is, on the second part of this demonstration of looking directly in the code and communicating with SkySQL, I want to show how we can use something called Jupyter Lab. And Jupyter essentially is an open source third-party notebook application that I can use to be able to run. In this case, I'm going to be looking at Python and using the MariaDB Python connector to connect to SkySQL, bring back the data from a cross-engine query, and then be able to display that using both the log output in code and also a visualization library called Plotly in order to show some graphs with this exact information. So first I'm going to, on this left-hand side of my Explorer window, I'm going to create a directory called Jupyter. And I am actually then going to exit MariaDB in my terminal, and I'm going to back up so that I can cd into Jupyter, and from there I simply want to type in Jupyter Lab. Now this is something that I've already installed, so it's going to work, but the process is extremely simple. So I want to kick off Jupyter Lab, and once I do that, I want to go ahead and remove this here. Whoops, I want to bring up my Jupyter Lab notebook, and I want to create a new notebook. So I'm going to select Python 3, and essentially I just have a Jupyter Labs notebook, which is untitled at this point. I could rename it if I wanted to, but what I want to do is start to incorporate the usage of the MariaDB Python connector to connect to SkySQL, and what that may look like briefly in code, but more importantly, how I can use that information from a data science perspective, right? Use the HTAP information and start to build visualizations that really help me get a better idea of the data underneath. So I'm going to go ahead and paste some things in here for the sake of time, but I'll explain them as I go. So first I'm going to import the MariaDB Python package, which is the connector for being able to connect to MariaDB databases. I'm also going to be bringing in Plotly, which is a visualization library that I'm going to be using to create some graphs. From there, I really want to create the configuration, because in order to connect to SkySQL, I actually have to provide a configuration. And this configuration needs to have SkySQL parameters. So as I look, I actually in here need to provide, it looks like I have the appropriate information that I need to for my SkySQL connection. Whoops. From there, I want to actually make a connection to MariaDB. And I can do that by using the connector and then just saying .connect and entering the configuration, which is going to use the information of my domain, my port number, my username, and my password to connect to MariaDB. Now, all in an effort to be able to create a cursor. The cursor, then I can be able to execute a query, and in this query I'm now going to have the cross-engine query, right? So the exact same or pretty close to the query that I just had, where I'm selecting airline, I'm selecting an average of the departure delay from my flights table based on the joins that I have of carrier. And then I simply want to fetch my results. Now, I can simply output this information, right, by printing it. That's something that obviously that I can do. So if I first go ahead and enter in a function then to call, make sure I get my indentions right in Python or it will not be running. Go ahead and enter in a call to print underscore stats. And this is simply going to print the top 10 of that cross-engine query. But as you can see, incredibly fast, and it's combining the information from both the row-based mechanisms and the column-based mechanisms. But this isn't very interesting to me because from a data science perspective, I really want to start to drill down in that information and use things like visualizations. So now that we've actually already brought in the Plotly code or the Plotly import, now I can actually bring in a method, and pasting a lot of code in here, but essentially what I'm doing is I'm going to be passing in my results, and then from the information that I've gotten from the results, I'm actually going to build both a bar graph and a pie chart. And then I'm just going to simply show those using this notebook and really the power of this notebook to be able to do some analysis in real time. And of course, if I want to be able to show this information, I can simply just add a call underneath and be able to execute. And so we can see that not only did I get my tabular information, but I also have a bar chart and a pie chart, which allow me to take a closer look at the information from a visualization standpoint. And this is really just the beginning of what you can do using tools like Jupyter, or there's other ones like Zeppelin, but they're pretty cool, and it's really fun actually to be able to write a cross-engine query, which combines the information from your row base, which is something that you would normally do, but being able to combine millions or tens of millions, billions of rows in aggregations on the analytical side is something from, as a developer, it just changes the way that you can write applications. So this is something that it's definitely available within SkySQL, but we also recently created a community server release 10.5 that actually includes the same capability as well. And the cool thing about that is that not only do I have samples that you can actually go and pull down from GitHub using MariaDB SkySQL, but I've also, in each of the samples, provided a way that you can connect to the community server container, which exists out in Docker Hub, to be able to do the same thing. So no matter how you do it, I suggest, if you're interested in checking out things like HTAP and looking in some of the newer things that MariaDB has been doing, go and take a look at those developer samples at MariaDB Corporation GitHub /developer-examples. Also, if you want to try SkySQL, it's completely free. You get a $500 credit to be able to start, and you can spin up transactional, HTAP, all of the service instances that we went over pretty easily. And if you have any questions or suggestions for any of this, feedback for me, I definitely appreciate. Please email me either at robh@mariadb.com, or you can email me at the alias of developers@mariadb.com. It also comes to me. Be sure to follow MariaDB if you're not already. And check out, again, the MariaDB Corporation GitHub account where I've put just tons of samples. And thank you very much for attending MariaDB Server Fest. I hope you have a great rest of your conference.
Next up, Federico Razzoli, playing with the Connect storage engine.
Hello everyone, Federico Razzoli here, and I will talk about MariaDB Connect storage engine. So who am I? I am a database consultant specialized in MariaDB and MySQL ecosystems, and I recently started this new company called Vetabase. So let's talk about Connect. Before explaining what Connect is, let's see what a storage engine is. Well, the thing is, MariaDB knows very little or nothing actually about how to write or read a row, or write indexes, caching data, and so on. So these functions are implemented in special plugins types called storage engines. If you know nothing about storage engines, well, whenever you create a table, it is of type InnoDB, which is the default storage engine, and it is absolutely a reasonable choice because InnoDB supports all the reasonable features, and its performance are ideal for the generic use case. Still, there are reasons to use different storage engines sometimes. So, an interesting thing is that actually when MariaDB asks, okay, Mr. Storage Engine, please read this row or write this row, actually Mr. Storage Engines could do anything. MariaDB will never know or doesn't even care. So, for example, Black Hole Storage Engine writes absolutely nothing. The data you insert in a black hole table simply disappears, as the name says. Sequence returns sequences of numbers. Spider is used to read and write data remotely, and it's used basically for sharding data over several servers. And CSV, for example, handles a file of type CSV on disk. So let's see Connect. If we run a simple query, we can see that Connect describes itself as a storage engine for management of external data. This means that it is conceived to read data from external data sources, understand them, and then do something with this data, as if they were regular SQL tables. So, and actually it's called Connect because it connects MariaDB to some other data in some other form. But other form can mean many things depending on the table type. So basically there are table types that read data from remote DBMSs. It could be MariaDB, but it could be also something else. There are table types that use data from files written in various formats, like CSV, but also JSON, XML, or many other formats actually. There are special data sources. For example, in Windows you can even see the information about available network interfaces. You can see this information as a table. And there are table types that make some kind of data transformations, and we will see at least one of them later. So we have just half an hour. We don't have centuries, so I can only talk about some specific things. We will focus on file-based tables, and then we will start playing a bit with Connect. So file tables can be of two macro types. Okay, they can be inward or outward. I'm using these terms as they are used in the documentation, even if I believe that they should actually be swapped. Okay, but anyway, basically a table is an outward table when we specify the file name clause, as in this simple example. Okay, we are creating a very simple table and we specify a file name. This means that we are going to use a file that already exists, and for this reason the file is considered somehow holy, okay, because it comes from the outside and we cannot ruin it somehow. Okay, so this affects the way alter table is performed. If we drop a column, for example, what will happen is the column will disappear from the table, but not from the underlying file itself. So what changes is if we can see that information or not, but the information is still there. If a table is inward, well, the underlying file is modified instead. So an inward table is a table based on a file, like in this example, because we are still using the table type CSV. So a CSV file will be created, but we will not use an existing CSV file. Okay, so we cannot specify a name for the file, but this is not a big problem because we can easily guess it. So the file name is the table name dot a meaningful extension, in this case CSV. If we are not sure about the name, we can run show warnings after create table, and we will see a warning which tells us the name of the file. Here I show a regex to take the file name from the warning. It's easy because it's simply the last word. So an interesting use case for Connect is the following. Receive data in a certain format that we understand, make some changes that is easy to make in SQL. So these are two trivial examples. For example, we only specify some columns, or we specify a group by, and then we export the result of this query in some in the same format or in another format as we prefer. So how to do it? Well, in the simplest case, we create an outward table. We use create table select to basically run the select that we want to run to make some transformations on the data and save the result in a connect table, and then copy the file elsewhere and then drop the table. Or if we want to make some more complex transformations, we can create again the outward table, run create table for the intermediate data we can use in ODB. Then we can add indexes. Then we can make some transformations on the intermediate data, and then we use create table select, and we can also specify well, of course, engine connect and the table type, and probably some other options to specify the format that we want to use. Like, for example, in this case, we specify that the separator character is a tab, and first line is not data, but is the names of the columns. And then, of course, we copy the file elsewhere and we drop the table. If we have an existing table and we just want to export it in some format supported by Connect, well, this alter table is probably the most efficient way to do it. Just keep in mind that this is an inward table, and therefore we cannot specify a file name and a path. but this is not a big deal, just you will need to copy the resulting file to some other place. So enough talking, let's try to read some Apache logs. We will use a very small sample, which is basically a sample of the Apache error log for database.com. The IPs are scrambled, so you will not see any secret. So here's some lines from the file, and okay, basically some considerations. The log uses a precise machine-readable format, but it's not very regular. It's not as easy to read as CSV or JSON. Okay, so we cannot simply use table type equal CSV and expect it to work. Okay, we will have to do something slightly more complicated, because we will have to define a mapping between the data written in the file and the columns those data refers to. Well, we don't care about all the columns. So, okay, this is a line, so this is the list of information we care about, so the IP, time zone, and so on. As you can see, between the various data there are some strings that are fixed. They are the same on all rows. So we will just have to communicate these strings to connect. So here's how we create the table. I will not explain every single line because it requires too much time. So, of course, we specify engine connect, then we specify table type FMT, which stands, I suppose, for format. We specify a file name with a path, because I think it's better for most cases. I mean, you don't want to simply put the Apache log into MariaDB data directory. It would be quite dirty and dangerous. And, of course, in the create table we have a list of columns, and you can see that for each column we specify field format clause. This is not MariaDB SQL. This is an option which is only understood by Connect. The most important thing to notice is these are like templates, right? Where we have % followed by another character. So %n is just a market. It means here the data that needs to be in this column begins, and then the next n means here the data ends. And then inside these two markers we have %s or %d, or we can have also something else. Basically it is the same format used by some C functions like scanf. And then before or after these markers we can have a fixed string. Okay, so it's easy to make mistakes while doing this. So unfortunately it's not very easy to find out what you did wrong. So the first error here is what we get if we probably don't specify a full path, or we specify maybe a wrong path to the file. And the following error message is what we get if field format is not correct for a certain column. It's not very informative, so if you get this error you will need to work a bit to find out what was wrong. So if we select a line from this data, we can see the result, and it's mostly okay, but you can see it's not perfect. So the time column includes a beginning square bracket. The time zone column includes a final square bracket, and protocol includes a double quote. These characters shouldn't be there, but basically I tried to exclude them, and I didn't succeed. After spending some time on it, I looked at the documentation and I saw they actually had a very similar example, but they also used some sort of workaround. Okay, so it's like, for some reason, we cannot have a perfect table for this kind of data. So instead of wasting more time trying to get a perfect result, which I don't know if it is possible, we can do this. We can have some virtual columns which basically use some SQL expression to drop a character at the beginning of the string, like in the first example, or at the end of the string, like in the other examples. Probably it is not really necessary, so we can have some additional trailing characters, and we don't necessarily need to care about it. But if we want to have complete data, we can use this trick. So this query shows that basically this works well. Now let's do some analysis on the Apache log file. Okay, of course, as you can see, we can run at this point any SQL query. So, for example, we can group data by a certain column. But what if we want, for example, to pivot the data? MariaDB does not support syntax to get pivoted results. Okay, but we can use a special connect table type which is called pivot. So before doing it, some forward. Connect tables that transform data in some way basically establish a connection to MariaDB just like any other client, and run some queries, and then get the results, and then transform the results in some way. But in order to do that, they need to use a username and probably a password. So it is a good practice to have a MySQL user in our databases. It exists by default because it's created by MariaDB install DB tool. So in this slide, you can see the create table that we can use. We specify table type pivot. We specify the name of the base table, which is weblog in this case, and usually the table is in the same database as the new connect table, but if it is not, we can specify a database name. Then we have option list, where we put, first of all, the credentials to use to connect to MariaDB and get the data from the base table. And here you can probably see why I suggest to use MySQL user, because it uses by default the Unix socket authorization plugin, and as a consequence it doesn't require a password because the authentication is actually done by the operating system. In this case it works because MySQL is the Linux user used to run MariaDB. So we don't need to specify a password, which is very good, because if someone inspects the table structure, well, they will see the passwords. I mean, they will see the complete option list. Okay, so the next two options are what actually define how the pivot works. and basically the pivot column is request type, and the function we're using is count, but we can actually use any other aggregate function like sum, AVG, or anything else. And you can see the result here. You can see that the values for the pivot column are, for example, get and head, and they became columns. But this result is a little bit inconvenient and almost unreadable. And to make things work, we cannot even specify select request type and then get and then head, because these special columns are created during the query execution, and if we mention them in a query, well, the query will simply fail. This happens because a pivot table type is meant for tables where we only have the column to be pivoted and aggregate data. This doesn't work usually for a log, but instead what we can do is to create a pivot table which is based on a query and not on a table. So in this slide you can see what we are doing. I will not show the whole create table again because it's a waste of time, and I will only show what's changed. Okay, the option list is shorter, and we add a source def clause, which basically contains the query to execute. And the query is very simple, is just a group by request type. Okay, so basically when we query the pivot table, each value from request type column became a new column. Okay, and the value is just the count as requested by our query. This is a very simple pivot table. We can do much more interesting things with pivot tables, but probably not in the case of a log, at least. Maybe we can, but I'm really not aware. But anyway, there are also other transformations that you can do with Connect. So you can see the other transformation here. So the occur table type basically unpivots the columns. So basically it turns columns into basically values of a single column. It is the opposite of pivot. Xcall turns string lists, for example, comma separated, into multiple rows. And table, basically, it's defined on a set of tables, and it allows to use them as a single table. So this was basically the last thing. What did we leave out? Almost everything, because the topic is huge. Connect really supports a lot of stuff, and we just played a bit with an Apache log. So we left out the other file formats like JSON, XML, HTML tables, fixed length files, which are familiar, for example, for COBOL programmers. We left out compressed tables because we could have read the Apache log in a zipped format if we wanted to. We left out the magic we can do with custom formats, so for logs in strange formats, the connections to remote DBMSs, MySQL, ODBC, JDBC, MongoDB. We left out that we can query remote REST APIs, which is not really simple because you will have to write some code for this. and it only works on Windows. But still, you can do if you really need it, and we left out more stuff. So to to make you not too sad for this, I'm including 2 final hints, which are, first of all, build proper indexes where possible, and then if your queries on Connect are still slow and the files you are working with are big, you can increase Connect work size cache, because it's the cache used by Connect, and if the size it is by default something like 60 mega. But if it's not enough because you are working with big files, you should probably increase it. And of course, if you have to do elaborated queries, well, also consider taking the data away from Connect and move them to some InnoDB table. Okay, so this was the last slide. So thank you everyone for attending. I hope that the talk was useful, and this is question time.
The next presentation, AMA with Monty. It is Mikael Videnius, the creator of MariaDB, who is inviting you to ask him anything. Welcome, Monty, Mikael Videnius, for the Ask Me Anything session.
Thank you. I'm looking forward to it.
Well, so am I. I have a couple of tricky questions for you. Lots of good questions here coming. We're monitoring the Zulip chat for further questions, so we reserve a bit at the end for the new ones, but I've already grouped the questions here into strategic questions and political questions and hardware questions and development questions. And I can tell the viewers I have not prepared Monty. We'll get the best more answers from Monty by being very spontaneous. So the first question, how do you feel, Monty?
Feeling good. I think the conference is doing great. I was really happy with Peter Zaitsev. He was doing good.
So what do you expect? Well, I won't ask you what do you expect people to ask. Instead, I will have pick the first question by somebody whom you know. You've met him in Albania, Tirana, 2005, Ervin Rucci. He's asking, is making MariaDB the fastest database your first priority?
Let's say you can never be fastest in everything, but I do have a sweet spot for performance, and I like to get the most out of the machine. So everything we do, or especially what I do, is regarding to do the best you can with little resources. And I'm happy to see that MySQL 6.0, actually, sorry, not MySQL 6.0, MariaDB 10.6 is about performance. So right. We have the whole team doing mostly performance things that should have been fixed a long time ago, or kind of just been forgotten. So I expect a lot of new interesting things.
A bit because your questions need to be fairly short because we have so many exciting questions. The second question here is an evergreen that I suppose you've answered many times before. How do you compare MariaDB with Postgres in one sentence?
I think they're both great databases, and it depends on your usage. If you're going to use a cluster setup, then I think that MariaDB is the better choice. We have more experience in that. If you are just using, have an extensible database and you have programmers and you want to do extensions, then Postgres is more suitable for that.
So then a question on the differences between MariaDB and MySQL. So MariaDB is innovating a lot, and sometimes this is from Abbas, is asking that it feels like they are becoming different products altogether when comparing Oracle MySQL, Performance Server, Maria. He believes that features like dynamic columns and JSON type support and InnoDB, ExtraDB should be available in all three. What's your take on that?
I think that we are more following the model that we had from MySQL time, where we trying to do stable releases and do maintain most of those, and something that is suitable for community to be part of. MySQL is not doing that. I think from the developed model is totally different. And from there also follows that the feature set that we add will be different.
So a follow-up question from Abbas was, do you think that a free non-BSL version, this is not related to MariaDB Foundation, but it's Ask Me Anything, so anyway, I will ask you, is such a version of MariaDB max scale, will it be made available for binlog use cases?
I mean, what we are doing, have promised, is that all the releases with all features will be available to the community after a certain time. And that's the whole idea with the BSL. So everything that is max scale is now will be sooner or later available to the community.
Hmm. Then we have another tricky political question. So Heinz is asking, what is the difference between the MariaDB Foundation and the MariaDB Corporation?
So the foundation is engineered to satisfy users and developers, especially people who want to do commit and help participate in developing MariaDB. And we also take charge of the code in the sense that we guarantee it is always free. The corporation, on the other hand, handles customers and requests where there has to be a timely answer and help when needed.
So what does that mean from a development perspective?
From a development perspective, the corporation has most of the developers in the MariaDB ecosystem, and they are paying those and driving development. While from the foundation, we have mostly handling pull requests from users, but we're also doing development on things that affects a big part of the user base, and also taking patches from including Percona, MySQL, and the whole community. So we take over the maintenance of those patches when they get into the server.
And what does it mean from a customer perspective?
From a customer perspective, it means that you get the best of the both worlds. You get open source development from a big community, and you have a vendor who can satisfy all your commercial needs and support needs.
So there, the presentation prior to yours was from Peter Zaitsev, and he had an observation that he found it interesting that when you download MariaDB Server from mariadb.org, after the download, you end up with a page from mariadb.com. What's your comment on that?
Yeah, we are trying to be nice within the MariaDB ecosystem, and the corporation provides both support both for the community and customers, and also the knowledge base and everything else. And they provide a lot of extra information that is useful for people who download MariaDB. So we made an agreement that they can maintain that and take that away from the hands from the foundation. I mean, there's no forced registration or anything.
Mm-hmm. Then Vincent is asking, what's being done to address the outstanding multi-year long bug reports, not long bug reports, but year-long bug reports for MariaDB, especially true for bugs that cause crashes or data corruption?
Let's say everything that is a crash with data corruption should have a ticket information that says that this is a major and it has to be fixed in the next release. So there shouldn't be any crashing bugs, at least not something that affects a notable part of the user base. There's always corner cases, but not corner cases should also always be fixed in the next release. Mm-hmm. So there's other feature requests that are not critical. They can be in the knowledge base, not knowledge base, but in the Jira quite long until somebody sees a need that get this fixed or added.
Okay, I still have some strategic questions left, but I also have a limited amount of time to ask you. So I'm jumping now to some technical questions. So James is asking, what feature of MariaDB are you the most proud of?
I'm actually most proud of something that's not many people think is interesting, that we actually take good care of our user base. We care about that upgrades are easy. You can take any MariaDB version and upgrade to the latest one or anything in between directly without doing something. And that means that you need to take good handling out of both storage, the protocol, and everything else, ensure compatibility. You can also take any old MySQL or MariaDB client and it will work unchanged to MariaDB. This is just so that you have no pain. I hate upgrade with passion because every time I upgrade my laptop, something breaks. And I'm trying to do my best to ensure that doesn't happen with MariaDB. When it comes to features, I think that the replications features we have S3, the online alter table, that's new in MariaDB. They are all exciting, but it's much harder to say which feature is the most exciting one. All developers are looking most closely to what they are coding themselves.
That came from the heart. So now Dion is asking, every piece of software, this is a fun question, so you can relax. Every piece of software can be made to do something it is not designed for. often when there's something far simpler and more suited to the purpose. So what's the single most ridiculous thing you've seen MariaDB being used for that it really just should not be used for?
MariaDB is kind of designed for being something that can easily access from the web. But I have horror stories from the old times before MariaDB and MySQL, where people were just misusing my products. But with the databases, if you try to store the wrong kind of information that is not designed for, then it's a bad thing. But I don't have any real horror stories of that. I'm more about real horror stories of the wrong uses of databases when we go to customers and when they complain about things work perfectly 1 year ago and now things are so slow. And you still today find that they don't have a single index. It's kind of incredible that MariaDB works even in those cases.
So now we're getting more technical. Hamza says that currently JSON as a data type is just an alias for long text when in MySQL, when would the MySQL-like JSON table be planned?
According to the SQL standard, JSON is text, and we are trying to follow the standard. And MySQL did something different for performance reasons, but our JSON is as fast or faster than MySQL, so we kind of proved that that was not needed. And so we are trying to follow the standard, and the only thing that is missing or big thing that is missing in MariaDB 10.5 is JSON table. We almost had it ready, but it didn't make the deadline for the release, so that will be in 10.6.
So how do you compare using JSON functions on the JSON data type with dynamic column functions on a blob data type?
Basically, it's more or less the same as long as you have one simple row. Basically, dynamic columns is there to say that you can have any amount of columns, not arrays or arrays, but just that. And that's the most common things. The benefit of dynamic columns is that every column is typed. So you know that when you put in a date, you get out the date and you can know it's a date. And that's one of the problems with JSON. You have no difference between dates, string, booleans, or anything else. So if you want to have typed and ensure that you don't get dates that is 32nd of December, you should use dynamic columns.
Mm-hmm. So I have two community questions. So for people who learn and use MariaDB, what guidelines do you have to provide to help learning the source code if you want to become a contributor? How should one behave?
To learn the source code is basically you take a problem and try to solve it, and then you dig into it. And we have tutorials in the knowledge base of how to do that. But when you get a stumbling block, you shouldn't just sit there and trying to solve everything yourself. You should go to the free node or preferably Zulip and connect directly with the developers of MariaDB who can give you hints. And that's the best way to learn. You can also use the email list to ask questions about how does this work and everything else. And especially the foundation, one of the purpose of it is to help newbies. So you can contact the foundation, and if you don't think that we have doing a good job through Zulip or other things, then tell us, and we will try to improve.
Mm-hmm.
But doing a pull request is the easiest way to get your code in. But the problem is, as you said, what should you do before you can do that? And then you have to use one of the channels.
Good. Okay, so then I have a fairly open-ended community question. What can I do to help you? So I don't really know whether this is a person who wants to code or write documentation, but if there's a developer who wishes to help with MariaDB Server, what's the type of help that we need?
I mean, you can help either with documentation, or you can spread the news about our fantastic MariaDB Foundation Fest and tell everybody about it. You can add help adding links to MariaDB Foundation and the project. but the best way is just to be active. Go to the email list or Zulip or Freenode and help other users. And you get much credit within the community when you're doing that. We can help both the project and also yourself when you want to get a job somewhere in the database environment.
Right. So,
and the last thing is that if you want to do the development in the knowledge base, we have a link for easy to solve issues, especially for newbies. Take one of those.
Mm-hmm. So then I got commercial questions. They are not really related to MariaDB Foundation, but hey, we said, ask me anything. So Joel is asking, could you tell us about the high growth of MariaDB in the Latin American market? Have you been to the Latin American market, and what's your take?
Personally, I'm not part of the group who handles customers' relationship in that market. But in Latin America, I have been attending MariaDB conferences during this wonderful time when you could still travel. I have been in Peru, Brazil, Argentina, and so on. So I really enjoy being in Latin America, and I would love to start going again when things start to open up. And yeah, but I know when I'm there, there's lots of MariaDB users, but I don't know how many commercial ones.
So the second and last commercial question here is by Santinesh. He's saying, is MariaDB working on some enterprise monitoring tool? And I hope you can say anything about monitoring tools that you know that will be interesting.
Yeah, so we did have some presentation about SkySQL, which is the in the cloud offering of MariaDB, and the cooperation of creating monitoring tools within that environment as a complement to our proxy. So that's kind of coming, and I don't know if the license of that eventually. Currently, you can try them out in the SkySQL cloud. Hopefully, we'll have them under BSL. At least that's my hope.
Okay, then two hardware questions here. Richard is asking, have you started to experiment with ARM server builds yet?
So we have ARM in our build bot. So every single push we do is tested on ARM. So from stability point of view, yes. From performance view, we haven't done any specific optimization for ARM yet. And for that, we need somebody to work with the MariaDB Foundation to make that happen, or the corporation.
So Samuel is asking, what's the plan with NVRAM?
So we already have some patches for NVRAM, in other words, persistent memory. And what we have now is that we can store part of or the whole of the InnoDB redo logs in there, which gives you quite a big boost in performance. And we are planning to do much more. But the question is that when will SSD truly replace hard disk, and when will NVRAM truly replace SSDs? We are trying to work with all vendors to ensure that whatever you are using, you will get the best performance that is possible with the database. As I said earlier, perfect performance is a passion, and I want to use the latest hardware to achieve that.
Mm-hmm. So one more technical question, and then I will go to a fun question. So John is asking about time series databases. Specialized time series database systems are all the rage, he says. How should one use MariaDB to store and query large-scale time series with billions of time series points in a table?
First, let's take it the black and or helicopter view. A time series database is one normal SQL table that has one index less. That's it. So the only thing that you really win with the time series database is that retrieval on time is faster because everything is sorted according to time. But with modern hardware, how often do you decide which database to use based if you have one index more or less? So I would say that a lot of the hype about time series databases is just that, hype. If you want to run with petabytes of data, we have column store who can handle that. It doesn't need time series because it internally does some of the same optimization that you would do in a time series database. So it automatically notices that in this block, we only have data for this time series. So we only examine that block. So you get the same benefit with column store as you get from a time series database in most of the cases. And column store is totally open source and free, which is not the case for many of the other time series databases.
Mm-hmm. So on that note, I'll still ask a follow-up question because you mentioned column store. So what are the new features that you're most proud of or that you want to highlight in the latest MariaDB version?
Regarding column store?
Well, regarding the latest MariaDB version, it may be column store if you wish to say that, or it may be something else.
In 10.5, we were more concentrating on ensuring stability and fixing things than adding a lot of new features. But the two main features that is totally new is the S3 engine and the column store engine. So those are something that people probably have not tried out, especially not in earlier MariaDB versions, and they definitely should look up on those because they can greatly change how your operations are working.
So then for the fun question, how the sea lion of MariaDB, it doesn't have a name, does it?
No, it's poor, nameless little creature. Do you have a suggestion?
Yeah, I was going to ask, what do you plan to do about that?
In the MySQL time, we had the same problem with a little poor orphan delphin. And we reached out to the community and asked, is there something you can suggest? And I think that we should do the same thing with the poor little sea lion.
Okay, and the suggestion, it should be a suggestion of the name, but should the suggestion contain something else than just the name?
I think that the best part of the MySQL Dolphin contest was that we got lots of really good names and explanation for why this name, and that was really, really funny and helpful, and that actually helped us choose Sakila. So I really would like to suggest that people who want to participate don't only come up with a good name, come also up with a short story, why and how the sea lion got that name.
So we will set up such a competition, such a game for people to suggest a name and the reason for why that is the right name. We will come up also with a deadline. We're talking internally about that at this point in time. But how do you then plan to select the right name for the MariaDB sea lion?
I have a perfect candidate for a judge who knows more about Maria than anybody else, and that's Maria, my daughter.
That's a good suggestion. So let us set up a competition for picking a name for the MariaDB sea lion. It has to have a name, and the name has to have a good reasoning, and it will then be picked out by the person named Maria Videnius, your daughter.
Yep.
So any conclusion?
And I think that, as probably people know, this channel is that Maria and also me are both artists. They do great things, and I think that the one who suggests the best name should get a picture from both of them.
That sounds like a great suggestion that I think we can implement. So any concluding words? Was there a question that you had expected to get that you did not get?
Not really. I'm here with a totally free mind.
So any concluding words, any wishes for the users that you wish to tell them?
Yes, please tell them that we are still continuing this fest the whole week. If you have people in China or Asia, please tell them that this is excellent time to join and get more information. And please spread the news about MariaDB to everybody you know. And about the foundation to all your developers, so we can continue the work that we are doing.
Right. So tomorrow, still later on today, we will continue in New York. Tomorrow is the third and last day of New York. Today is the last day of Paris. And as you say, on Friday, Saturday, Sunday, we'll do Singapore and Beijing. So that's the end of the first MariaDB Server Fest that we're having this week. So with those words, thank you, Monty. Thank you, Mikael Widenius, for the Ask Me Anything session.
Thank you.
Our next presenter comes from Codership Galera. It is Seppo Jaakola, who will be talking about MariaDB Galera cluster.
Welcome to MariaDB Server Fest 2020 and a presentation about MariaDB Galera cluster. My name is Seppo Jaakola. I'm a CEO and developer of MariaDB in Codership. I have a quite long track record of clustering solutions, already 15 years and over. Codership itself is a small technology company focusing in research and development, mostly around replication solutions for open source databases. Galera cluster is our product. We have started to work on that in 2008. We do business through support and consulting, and we are partner of MariaDB, and we are member of MariaDB support team for Galera related topics. Agenda of this presentation is just a very general overview of Galera replication, Galera clustering in MariaDB. There will be another presentation about Galera new features you can find in Maria 10.5 and 10.6. That presentation is also in a MariaDB Server Fest happening later on. But this is quite a general overview, just basic concepts of Galera clustering. I'm looking at the configuration of Galera cluster, how you can turn your MariaDB server to work as a Galera cluster, synchronous multi-master cluster for MariaDB. An overview of the features of what you can gain with such cluster solution, and then a few words about the releases and release cycles of the Galera releases. So let's go ahead. This is a standalone MariaDB server you can get from the MariaDB distributions. So you have clients connecting to just one MariaDB server. If this is a MariaDB 10.1 or later, you already have all the Galera software installed in your installation, so you can just by configuration turn it to operate as a node in a Galera cluster. Galera is a plugin, replication plugin, and in a configuration you need to tell that where the plugin resides. You have it in your installation somewhere on your disk. Documentation should tell where it resides. And in a configuration variable VSREP provider, you give address to this plugin library implementation. And with that, when you start your server with such a configuration, you have a single node MariaDB Galera cluster, just one node in a cluster. That's not yet a very functional cluster, so you need more members. You should start a secondary node telling where it to use a Galera plugin, and also you must tell that the address of the other node in a cluster. The address is given with a configuration variable VSREP cluster address, and it's practically just the IP address of the other member in a cluster. In principle, all nodes that you configure for your cluster should have the VSREP cluster address specified, and it's a good idea to give them the full list of all potential members that your node might want to join to form up a cluster. So if you have 3 nodes, you should in your VSREP cluster address list all these 3 IP addresses. This VSREP cluster address variable is used only for the handshaking of the handshaking part of the protocol when the nodes join to the cluster. After that, the VSREP cluster address variable is not used at all. The third configuration variable here is VSREP SST method. It tells the method how a new node joining to the cluster can get the copy of the database, so that it would have the same data content as the rest of the cluster has. Here in this example the method is rsync, so the joining node will just get an rsynced copy of the data directory. So all the files that are present in the first node will be just copied over the internet to the joining node. And with this configuration, the cluster will handshake with the joining node and then send the fresh copy of the database through rsyncing to the joining node. And when this copying is complete, the node will be an active member in the cluster. All transactions happening in both of these nodes, actually, they will be synchronously replicated between each other. However, 2 nodes is not yet a very functional cluster. You should have 3 or more. So you just need to make another installation of the same MariaDB server, configure the plugin and the cluster addresses correctly, and then join the node. And then you have a functional 3-node cluster. This is the minimum recommended size for the cluster, just for the sake of these nodes or the cluster to decide that if there are communication problems between the nodes, then the cluster must find out if there are 2 nodes who can communicate with each other, then that part of the node will be the majority, and the 3rd node will be kicked out for a while until he gets a better connectivity with the rest of the team. 3 nodes is the minimum number to make a meaningful voting in error situations. Usually the clusters that are deployed, they are 3, 4, 5. These are maybe the most used cluster sizes. People are usually using Cholera cluster for data safety reasons. The more nodes you have in a cluster, the more copies or backups of your data you have actually in place. Every node in a cluster is a full backup of each other because of the synchronous replication that the cluster is carrying out. All writes in the cluster, they will be replicated immediately to the cluster. If you write to the middle node, the transaction will be replicated, and the transaction will be committed only in the middle node. In this example, it will be replicated to the 2 other nodes, but not necessarily committed yet before the client gets the OK status back from his commit. So we know that the commit is really complete in one node, and it may or may not be complete in other nodes, but every node has the transaction, has received and acknowledged the transaction. And also these nodes, they will, when later on, commit the same transaction. That much guarantee for synchronicity Cholera cluster provides. All nodes can be used for reading, so you can safely read from any of these nodes. There are nothing preventing that, of course, and the reads are very close to each other, so the cluster progress is very even. It doesn't really matter where you are reading from. you will get the same results in practice. In a nutshell, Cholera replication is a generic plugin for any database server. When we started to implement the Cholera clustering, we first defined definition of API between any database server and a replication plugin. And this project there's a separate project for this. We call it Write-Set Replication API project, or VSREP for short. These clusters that are implemented with Cholera, they replicate write sets, which is practically the change set of happening in a transaction, and this change set is then replicated over the replication layer and then applied and made persistent in every other node in the cluster. When a database server provides this API, then it can load Cholera plugin, and with that there is one node of a cluster, and having more of these nodes will build up a database cluster. With MariaDB having a MariaDB 10.1 or later installation, you just make a configuration through vsrep_variables, and then you can start playing with the cluster itself. Here is the full list of configuration variables available for Cholera clustering. This is listing from MariaDB 10.4, a big number, very small text, but let's not go through this list in more detail. In practice you only need just a handful of variables for tuning. Usually it's about telling the provider and the cluster address and the SSD method. That usually is enough for configuration. There are also status variables just to see that how the cluster is doing, and monitoring tools use these status variables. In Maria 10.4 the number of status variables for VSREP is 66. Three most used ones are VSREP ready for the cluster readiness of accepting transactions, cluster status, and cluster size. Usually monitoring solutions pull these variables to see that the overall status of the cluster. Then there are a big number of other status variables to see that how transactions are doing in a cluster, or all other aspects of the cluster healthiness. Besides of these variables, configuration variables and status variables, there are also free tables for cluster information. You can find these in a MySQL schema, VSREP cluster, VSREP cluster members, and VSREP streaming log table. The cluster table is just a definition of the cluster, the name of the cluster. VSREP cluster members, it has more information. It lists all the active nodes or members of this cluster, their names, addresses, IP addresses, and UUIDs for these nodes. So if the cluster size is 3 nodes, you should see 3 lines in this cluster members table as well. And finally, streaming log table. It's about a new feature that we added in Cholera 4, which incarnated in MariaDB 10.4 release for the first time. Streaming replication is a method for replicating very big transactions or very long-term transactions as well. Cholera 3 and earlier installations had a problem that if the transaction size grow over a certain limit, it could cause problems or big delays for the cluster, just because of the size of the transaction was too much for the replication system to handle. with streaming replication that we implemented for Galera 4 installations, we are splitting the big transaction to small parts, which we execute in every node at the same time in the cluster. So the transaction is kind of processing in small pieces in every node in the cluster. And the status of and state of this transaction execution is stored and maintained in this VSREP streaming log table. It can be, we use it, we as a Galera developer, we use it for guaranteeing recovery for such long-term transactions in case of any cluster problems, node hangs or node crashes or reboots. We can always take back the long-term transaction. But it can also be used for monitoring and just picking that what kind of long transactions you have in your system, how long they have been processing, and it could also be one method for troubleshooting if there is a ill-behaving long transaction going on in the system. The features that Galera cluster brings is first and foremost is synchronous replication. As I said, it's not fully synchronous, it's close to fully synchronous, but the commit is guaranteed only in one of the nodes in a cluster. But you can see that, or make your session to have a, we can call it a look and feel of a synchronous replication. There is a session variable VSREP sync weight which you can specify so that your, for example, your reads, when you read something from a node, it would wait until the slave replication queue is fully committed, so that guarantees that you will see all the earlier writes. You won't start processing your reads before you all incoming writes have already committed. With that makes reads somewhat slower because you have to wait until replication queue is committed. The good news here is that the replication queue is usually very short, and that's because Galera cluster implements flow control, so that if there are pending transactions goes over a certain limit, by default it's only 16 transactions. So the queue can you can queue up 16 transactions, and after that the cluster starts sending flow control stop signals so that every node will wait for the slowest member, and keeping the pace of execution in the cluster for even for all of the nodes. Therefore, having the VSREP sync weight configured usually doesn't cause too much delay for reads as well. The installation for Galera cluster nodes makes those nodes to be equal in terms of reading and writing. You can always read from any of these nodes. You can write to any of these nodes. Galera cluster does not give you any, does not stop you doing that. But if you want to use Galera cluster as a master-slave topology, you should have a read-write splitting happening in upper level in load balancer or proxy, or sometimes some applications are clever enough to figure out that where to write to and where to read from. But for Galera cluster there is no restriction. You can always write to any of these nodes. Most installations are working in a master-slave model, so that the application or the load balancing layer will provide this read-write splitting and managing it. It's for simplicity reasons mostly. Also, Galera cluster can sort out conflicts, so you can write to any of these nodes, any table, any row. There can be row level conflicts, but Galera cluster will pick a winner and loser for any conflict, and the loser will just roll back the transaction and get a deadlock error as well. Galera cluster can retry a failed transaction because of such conflicts, so that the client doesn't even get the deadlock error. Cluster retries it, and if it's successful, the client will see that my transaction execution took 2 times longer than usually, but it was successful. So this kind of automation is also possible to have there for multi-master use cases. And finally, we have added quite a lot of automation for Galera clustering. So in principle, you only need to make the configuration correct for all the nodes. You specify the cluster addresses correctly, and after that, if you start a node, it will automatically join. Eventually, if the database size is big, if it's terabyte, it can take hours, but eventually it will be a member in a cluster. I have a copy of the database and then will be a member in a cluster. If a node drops out from the cluster for any reason, it will usually retry to join, and it might be that the administration doesn't even know or see the effect that node went out before it has already automatically joined back to the cluster. That could also happen. How much different this is then with respect to asynchronous replication? Practically all what was listed in the previous slide are actually the differences between Galera replication and asynchronous replication. In asynchronous replication, you can only write to master server, and then all the slave servers they are used for read-only purposes. Slave nodes, they may fall behind, so there can be slave lag, and that's because there is no flow control in asynchronous replication topologies. Master is as fast as possible. They allow us any transactions to come in, and if the slave servers cannot keep up with the pace, then they will just fall behind. If a master server needs to be replaced for some reason, then the whole topology must be reconfigured so that there is a new master. New master must be picked up, and every server must be configured to know that where the new master resides. So that's a management burden to have all that organized. If you are using Galera cluster for master server topology, you just write to some other server node in a Galera cluster, and that's it. So no failover needs because of Galera in such scenarios. How about the versions then? So we started the Galera development in 2008, quite long stretch already, like 12 years of Galera development. First versions for MariaDB came, if I remember correctly, for 5.5 and then also 10.0. But starting up to that point, there were additional Galera clustering implementations that were not part of the MariaDB software stack itself. But starting from 10.1, Galera clustering is accepted as in MariaDB mainline. So with later MariaDB releases, you get a Galera cluster, Galera replication included, and it's up to you to make the configuration to start using Galera cluster. Turn your MariaDB server to a cluster working with Galera replication. We have given Galera major version numbers starting from 1, and most recent one is now 4. These are versions that make a big impact for the overall behavior of the cluster. They also contain a jump in the VSREP API, so the replication API has changed, and the way that the Galera plugin and database server communicate has been changed, and because of this changes in this API level, then whenever there is a major Galera major version upgrade, it means that we also need to prepare a rolling upgrade path for the solution. For database users, it means that when you step, for example, the last big change was between Maria 10.3 and 10.4, and upgrading from 10.3 to 10.4 needed to happen in a certain way to make it safe. You need to have your first all your nodes in a cluster to be upgraded to the latest 10.3 version, and then node by node, just upgrading one node in a cluster to operate as a 10.4, and then the second node, and when the last node of the cluster has been upgraded, then the cluster is in the level of 10.4, and after that the internal replication in cluster starts to use the Galera 4 replication methods. You cannot downgrade after that, so your cluster is then in a Galera 4 level, and your upgrade is complete. This rolling upgrade is usually quite tedious job to do, so testing wise we have to do it, reserve quite a lot of time to do that carefully and make sure that all live systems can be safely upgraded to the new version. Because of this, we want to pack all changes for the replication API to happen not so often. So the Galera replication 4 came with Maria 10.4. Now we have a 10.5 which is using the same VSREP API level, and for Maria 10.6 we have not yet decided that what kind of features will go in there, but it may be that there's a major change in a Galera or not, but this is something to be decided in actually quite soon, in a matter of 1 or 2 months. Alright, last slide here, summary of this presentation. Galera clustering itself, it's present in MariaDB releases for a very long time. Starting 10.1, it's already in every Galera MariaDB release. Reason to use it, what people are saying is that synchronous replication first and foremost, quite most often looked reason. Then the data safety, because of the fact that every node is a full backup of each other. That's also seen quite important feature. And multi-master needs sometimes not so much that we were anticipating when we started to use the develop a Galera cluster. We were hoping to see the performance impact of writing to several nodes, but that's not something that that the applications need so much. But it's multi-master use case is good for generality, so that you could treat your cluster equally. It doesn't matter. You don't need to care where you write to, and if your application is not sensitive to conflicts, write conflicts and seeing deadlock errors, then this might be a good solution for such application as well. Galera works well in wide area network and cloud installations. No problems there. It's mostly because the replication itself it's not sensitive to latencies in the network connections. Galera 4 came with MariaDB 10.4, and it has 10.4 overall has significant new Galera 4 features and other MariaDB features as well. So if you want to start evaluating and experimenting with Galera, I suggest you begin with 10.4 or later, just to avoid the rolling upgrade that you would need to do when you if you are in 10.3 or earlier, you have a one sure rolling upgrade experience coming up quite soon. This rolling upgrade, as I said, it's supported so far for all versions, and that's our policy that our users, they are usually running clusters which need to stay up 24/7. There is usually not much accepted downtime for the cluster, and because of that we need to make sure that whatever we release, it's possible to upgrade online in a hot system. That's all from my part, and I guess questions are coming in a separate session after this airing, and don't forget the next presentation. It's also coming from Cholera cluster about 10.5 and 10.6 new features coming later. Thank you and bye-bye.
Now for a look forward, the Galera clustering in MariaDB 10.5 and beyond by Seppo Jaakola.
Welcome to MariaDB Server Fest 2020 and a Galera cluster for MariaDB presentation. My name is Seppo Jaakola. I'm a CEO of Codership and a MariaDB developer. Codership is the smallest technology company focusing in research and development for open source replication solutions. Galera cluster is our main product. We have been working with that since 2008. We do business through MySQL and MariaDB consulting and support, mostly with MariaDB Corporation. Since 2007 we have been doing continuous growth, and our team is growing constantly. Here is the agenda for this presentation. This is about Galera cluster in MariaDB, the latest features of that, so it's more technical. There is another presentation in MariaDB Server Fest, which operates more like an overview on an introduction to Galera clustering. In this presentation, I first talk about Galera releases, how Galera came to be in MariaDB. Then the newest major features, practically Galera 4 in Maria 10.4, and new features we have been adding in MariaDB 10.5. And also some features that we plan to put in 10.6. The development for 10.6 has already started with our team. Galera cluster development, it started in 2008. It was first only for MySQL, but quite soon we all started to develop also versions for MariaDB. Up to 10.0 release, the Galera clustering in MariaDB was an add-on product, so you had to have a separate installation for MariaDB Galera cluster. But then since 10.1, Galera has been integrated in MariaDB mainline, so if you have a MariaDB 10.1 or later, then you also have a Galera product included. It's only a matter of configuring your MariaDB server to work as a Galera cluster. 10.2, 10.3 were just minor releases from Galera perspective. There were many major versions, of course, for MariaDB, but for Galera clustering, not that big improvements. But in 10.4 we had a Galera major upgrade. We started to use the latest Galera 4 replication there. It included also the replication API change, so the integration or migration from 10.3 to 10.4 requires more attention because of this. And 10.5 came out this summer. It's the latest from our side, and in this presentation I look mostly on the features that came in 10.4 and 10.5 and also the new features planned for 10.6. When we talk about Cholera releases, we have divided major releases with just a small integer number. We started with 1, 2, 3. Now the latest one was called Cholera 4, and that's present in MariaDB 10.4 version. The replication API that we call VSREP API, it has also integer number, but it goes from 1 to 26, so there has been much more API changes than the major Cholera version changes. But what matters for the end user is that whenever the replication API is changed, then the upgrade can be more challenging. It requires a rolling upgrade path, and that's what actually we had to do in our development, so that we test that carefully and provide a way to have make it possible to upgrade a full operating cluster without any downtime to the new version of Cholera replication. Cholera 4 releases in 10.4, it included this API change, as I said. The latest VSREP API is number 26. The biggest feature that we brought in there is streaming replication. Streaming replication was originally implemented to support big transactions or long-lasting transactions as well. Here is an animation that how streaming replication can support a long-term and a big transaction. We have a client and a free node cluster. When the client starts a big transaction, it first launches in the first node, but as soon as we detect that the transaction has a big size, we replicate it to the cluster so that every node in the cluster will also launch a matching stream replication transaction. And when the transaction processes, it provides some result sets. All these results are then replicated, so the transaction is live in all of the nodes in a cluster. So in a sense, it's a distributed transaction processing system. And when the client finally commits, all these transactions will commit in the same time. It looks quite simple from surface, but developing this and making sure that it's always safe to use that, and it's also safe when there are changes in the cluster. Let's say that the node goes down or more nodes join to the cluster while there are ongoing streaming replication transactions. The cluster does not know that when the transaction eventually will commit, so there is no guarantees that upfront that we could decide that should we wait or not for certain operations. The cluster must be able to handle all possible situations. Because of this, and to make it safe, the development cycle for streaming replication alone was very long. It was like 3, even 4 years to take it from drawing table to the final release. We were suggesting streaming replication already for MariaDB 10.3, but it didn't catch that train. Then it was delayed, and finally in 10.4 we got the streaming replication in the MariaDB releases. GTID compatibility work started for 10.4 and is now present in 10.5 release. It's a work done by Mario Caruso. The underlying problem or the challenge of GTID support is that Cholera has a GTID of its own. It has two elements, UUID and a sequence number of the transaction, whereas MariaDB has a 3-element 3-element GTID with domain ID, node ID, and a sequence number. The plan and design for GTID support now for Maria 10.5 is to make Galera cluster to also provide similar GTIDs in the format of MariaDB. For this reason, we use the same domain ID and node ID in every node in the cluster, so that the end user of MariaDB cluster would see the cluster as just one single MariaDB server with the same domain and node IDs. Galera cluster will now store and show for the end user only MariaDB format GTIDs. And Galera cluster can also operate as a slave for external MariaDB master server, and the GTID coming from the MariaDB master is also preserved in a Galera cluster, so you can find the same transaction that was committed in the MariaDB master server. You can find the same GTID also in the binlog files of a MariaDB Galera cluster. Cluster error voting is also a feature that came with the 10.5. It's worked by Alexei. The idea here is that there is a new protocol for cluster nodes to agree what to do when one or several nodes in the cluster have problem in applying of incoming transaction. The problem could be suspected inconsistency or some other reason for not being able to apply the transactions. Here is an animation how it goes. We have one client sending a transaction, maybe a problematic one, and a 5-node cluster. The client finally commits the transaction. As usual, the commit is replicated to the cluster. Cluster is happy with it, so the commit gets OK status packs. Client thinks that commit was successful. Well, it was, at least in the first node. But the applying of this incoming transaction, it can happen somewhat later. And in this case, 2 of the nodes have problems in applying the transaction. So they saw that this is not possible. And now the error voting protocol kicks in. The first node seeing the problem sends a message to the error voting protocol, and then every node in the cluster starts to vote, telling that what was my success with this incoming transaction. The healthy nodes say that okay, this I had no problems, but 2 of these nodes tell that I had a problem. And when every node sees the votes coming, then the nodes that see that they are in a minority, they will just shut down. And as an end result, we have only 3 nodes in a cluster. From the end user perspective, he issued a transaction. It was good. And also the cluster is good after that. But 2 nodes went down, so the DBA should step in and take another look at why these 2 nodes failed to apply the transaction, and then fix the problem if there is some, and then rejoin these nodes back to the cluster. XA transaction support work by Daniele and Leandro. What we mean with XA transaction support is that we want to make it possible for Galera cluster to operate as a resource manager in an XA infrastructure. So there's a transaction coordinator somewhere else who wants to operate with several resource managers, where a Galera cluster is just one of these resource managers. So Galera cluster should be able to prepare an XA transaction, and after prepare to either roll it back or commit. If it has prepared a transaction, it also must be able to commit if the transaction coordinator wants him to commit the transaction. This XA transaction support is possible after we implemented the streaming replication. We use the streaming replication as foundation for running XA transactions. We had this work already ready for 10.4 release, but it was not accepted there, and we moved the target to 10.5, and we almost got it there. During last springtime it looked that okay, we have a Galera XA in 10.5, but what happened there behind the scenes is that 10.5 had also some other work related to XA transaction support in the MariaDB proper side, and that work conflicted with our work for Galera replication, and we had to wait to get the MariaDB XA implementation first in, and finally it came out that there was not enough time to get our work done and well tested, so we left in a situation where we had to just pull back the proposed Galera XA support for 10.5 and delayed it to be scheduled for 10.6. So it's a practically 1 year delay for getting XA support for Galera cluster in the MariaDB. I have two features, non-blocking DDL, to discuss also. It's quite long-term work that we did. My font is yellow here because this is not in MariaDB community server, it's only in MariaDB Enterprise Server Edition. For that reason I'm not in this presentation going through the details. I'm just telling you that this work has been done. It probably will be later in MariaDB Community Edition as well. This is work by Teemu, and the idea with the non-blocking DDL is to execute the DDL in 3 phases, where phase 1 and 3 are blocking ones, but they are very short. We do those phases just to agree on taking a metadata log for the later coming DDL operation. The phase 2 is the long-lasting phase where the DDL is actually rolled into the system, but the cluster is not logging that phase. There is only the metadata log protection for that operation in place. For configuration, we have one new online schema upgrade method, NBO, that can be chosen. People usually use the total order isolation, but with the MariaDB Enterprise Server it's possible to use the blocking operation as well. Another one on MariaDB Enterprise only feature is black box, work done by Pekka. Black box, in a nutshell, it's a debug message storage held in ring buffering main buffer. So when the MariaDB server is operating, it stores all kinds of debug level information in a quite small area in a ring buffer, and if the server might crash brutally, we can always go back to the black box to take a look at what happens in the last seconds when the node was still running. It helps in troubleshooting a failed cluster, or we have found out also that it's very helpful in testing, cluster testing as well. And finally, the last slides of this presentation is about MariaDB 10.6 planning. We completed our 10.5 related work in early summertime. We have this XA transaction support that was practically ready for 10.5. We continue with the testing of that and also documenting it, so we should be very well prepared for 10.6 release to have the XA support finally in. But this implementation, one of the reasons to implement XA transaction was our interest to fundamentally to implement the sharding cluster based on Spider storage engine, and this work we can now do. the spider cluster would operate like this. So we have the spider cluster is the upper level cluster with 3 nodes using spider storage engines, and then we have a cluster for each shard of the spider engine. In this example, there is only one table spider which is belongs to the spider storage engine, and it has 2 fragments A and B, and each of these fragments is then served in respective Galera cluster. The left hand side shard cluster has 3 proper Galera nodes, and the purpose of this cluster is only to serve the incoming XA transactions related to changes for the fragment A of the spider engine table. The right hand side shard cluster has 2 proper nodes and an arbitrator, so that would be the minimal deployment type of a sharding cluster. 2 proper nodes for data safety, and then the arbitrator for all kinds of voting situation if the cluster has some kind of hiccups in the communication. In real life, you obviously will have a lot more fragments or shards in your table, and a big number of servers needed to run these kind of topologies. But this is interesting work, and mostly because it's the way to the final way to the write scalability. The performance and kind of the workload in each shard cluster is quite minimal. It's only each shard cluster needs to care only about the data that's one part of the big table. So the load per shard cluster is quite minimal. The only question is for the overall throughput of this system is that how big a bottleneck the spider engine will be in the upper level spider cluster. We have started some ongoing work for 10.6 as well, so the XA and spider cluster testing will be of course part, but some other work that we do for 10.6. We started with the test system improvements. That doesn't show up for the end user so much, but for development it's very important part. We are extending the test coverage and improving the tests so that they would be deterministic and not so false positive so often. It will help in the development and avoiding regressions in the future releases. 2 new features have been worked on. First one is dynamic SSL or TSL encryption. Earlier you had to either use SSL encrypted group communication or not. You needed to do that up front, but now you can dynamically switch on and off, and you can change, for example, your SSL implementation to have another implementation variant of the encryption used for the cluster. This work is code complete. It's in a testing phase at the moment. Another one is the optimization for streaming replication. The way that we implemented streaming replication for the first version was very conservative and safe, just to cover all the possible error scenarios when cluster has members dropping from the cluster and joining in, and we had to make sure that it's always possible to recover an ongoing streaming transaction. Because of this, we used quite a lot of extra resources, and that caused the actual long-term transaction to last a lot longer than it would in a for example compared to a single node or a standalone MariaDB server operation. But with this optimization we plan to make the transaction throughput of such large transactions much faster. This is in a research phase, and the implementation has just started based on the design that was done in a research phase. So these 3 tasks are ongoing. Then we have a list of feature requests that we have got during the 10.5 cycle, and what we are hearing from MariaDB Corporation as well. The list is quite long, like 20 to 30 new features. We cannot do all that for 10.6, but during the next 1 or 2 months we will pick up the winning features that we want to put in 10.6 for the next springtime. Yes, that's about all for Cholera Cluster 10.5, 10.6 for MariaDB. Thank you for listening, and have a nice MariaDB Server Fest 2020.
Our next presenter is from China, Pengfei Ma, MariaDB clusters on Kubernetes.
Hello everyone. I'm very glad to participate in the 2020 MariaDB Feast conference. My Chinese name is Ma Pengfei and my English name is Matt, the product manager of Watch Technology. I'm responsible for the product design of cloud native database. Currently, the product has deployed more than 400 nodes in private and public cloud environment. Today, my topic is MariaDB database clusters on Kubernetes. The challenges of MariaDB database clusters on cloud we have been met as following list. First, network solution of hundreds and thousands MariaDB instances over multi-data centers. The most complex part of the public cloud is the network solution. It involves the deployment and scheduling MariaDB instance over multi-data centers. Fortunately, Kubernetes has provided mature and stable network solutions, such as Calico and Freno. Second, cost-effective computing resource. Because each server node runs many MariaDB instances together, the CPU, the memory resources required for all MariaDB instances in a server more than the hardware limitation. Third, portability and easy scale-out. MariaDB clusters be able to deploy multi-released operating system like Red Hat, Ubuntu, Linux, and easy to scale out the MariaDB cluster instance and the server nodes. Fourth, self-healing and auto failover. Because it is impossible to manually operate and maintain huge numbers of MariaDB on cloud. It needs self-healing capabilities such as offline failed MariaDB instance and online new one replaced. Fifth, save disk space. Software and applications are built by Docker engine into image as a running container on Kubernetes. Multi-MariaDB instance running in a server can ensure the best images due to the Docker storage driver. So let's take a slide of Kubernetes architecture. The Kubernetes architecture departs into the control panel and the work node panel. In control panel, it has three components: API server, scheduler, and the controller manager. On the work node side, as a Kubernetes and the proxy, we usually use the Docker engine as our container runtime. Both of the components only interact with the API server. We can use the kubectl command to apply the YAML file to tell API server how to deploy our resource, and all the metadata is stored in the etcd. And in Kubernetes, there has so many built-in objects, and it provides powerful resource management. For example, we can use deployment to deploy stateless applications such as PHP admin and MaxScale. If MaxScale becomes computing bottleneck, we can quickly add a replicas number to improve throughput. Daemon set used to deploy system component such as the Calico, because the Calico needed to run in each node to allocate IP address for every path. Stateful set. Stateful set is to deploy stateful service such as MariaDB, the MySQL database. It requires that each pod bound with the PV to persist the data. The job is task management. We can perform a backup task for MariaDB clusters. like the cron job or once backup job. The service can automatically discover backend MariaDB instance in Kubernetes and do load balancer. So take a look at an example of using server set to create a MariaDB instance. This is a demo YAML file of server set. The advantages of creating pods with server set is that each pod has its own PV, and the name of each pod will be prefixed with the metadata field name defined, and plus order the number from 0. For example, the first replica named MariaDB 01, second named MariaDB 02. The YAML file also includes the container image version, the Docker registry address, the storage class. The storage class provides the PV volume, and specific the directory where the PV mount. When a pod to be scheduled, the server set will create a new pod replace, but it retains the original name, network identifier, and the bound PV volume to maintain the pod state. The controller workflow is shown like this. First of all, we preparing a YAML file contain server set manifest, and through the kube control applying it to API server. And the controller manager, server set is one of the controller manager, by the way. The server set controller lists the list of API servers newly resourced and create pod manifest. Newly created pods now stored in etcd. The scheduler chooses the best node for the pod assigned to the node. The Kubernetes watch API server and see a new pod scheduled to its node. It tells Docker, the Docker engine, to run containers. Okay. We use server set to deploy a single instance of MariaDB so far, which has certain fault tolerance. However, MariaDB clusters on production environment need high availability, like MariaDB master slave or Galera cluster solutions. The backup strategy, the automatic do the backup and the recovery of the MariaDB instance. Monitoring the running database metrics, the read-write split. I use the proxy, the max scale to the read-write split. On rolling update, as the MariaDB official released the patch, we needed to do it. Agility means the MariaDB clusters and the server nodes are easy to scale out when we needed more computing and storages. All above features we can be achieved by extending Kubernetes API. We can customize the API objects interaction with a specific controller. For example, the extended API object is named MariaDB cluster. It tells Kubernetes that our MariaDB cluster is composed of 2 MariaDB HA instances and 2 read-only slave instances. The controller inside Kubernetes regularly compares the current MariaDB instance running state with our expected state, and find out that there's only one read-only instance running, so the controller would create a new MariaDB instance according to the logical we defined to start a new pod for MariaDB slave, configure MariaDB slave replications to the master, and do the data balance. And the pseudocode is like this. There has a for cycle, and the get desired state function returned our expected desired get current state function return the current running status. The recancel function will compare the desired and the current status and do our logical. So the MariaDB cluster controller is like this. We have already extended the API of the MariaDB cluster into the etcd, and we're preparing a YAML file. The YAML file contains MariaDB cluster manifest and through the kube control applying it to the API server. Once we have our specific MariaDB cluster controller, the MariaDB cluster controller manager list of API servers newly resourced and create a related stateful set manifest. And the stateful set controller will notification through the watch and create the pod and the workflow we have mentioned before. The MariaDB cluster controller, we create two stateful sets. One stateful set, the metadata name is MariaDB HA, labeled DB role HA. And another stateful set named MariaDB slave, labeled DB role slave, and the spec the replicas number is 2. And each stateful set exports the service to adjust the backend MariaDB IP. In front of the MariaDB clusters, you can use the Kubernetes deployment to deploy the stateless proxy max scale and configure the master and the slave address on the max scale configure file with the name of the two stateful sets. Expose the service respectively. So we can get a MariaDB cluster. We can get a MariaDB clusters composed of two MariaDB HA to MariaDB slave using the max scale proxy to carry out read-write split. And let's take a look at the MariaDB cluster internal. Kubernetes pod is the basic scheduling unit. We can run multi-containers in a pod. This container shares the network storage, etc. It seems to run on a local host and will be scheduled together by Kubernetes. We package the MariaDB instance, self-developed leader, and the actual program into a pod. When we create a group of pods through the MariaDB cluster controller, the MariaDB instance inside this pod has been started with the read-only start, and their leader components will communicate via TCP protocol. When one of the leader in MariaDB HA labeled pod acquired the lock, it sets the MariaDB instance read-write become the master role. Another pod leader notifies their MariaDB instance to execute the change master command to the pod. This leader component communicates regularly to update its states. Assume that the current master MariaDB instance is out of work. Another MariaDB HA labeled pod acquired the lock. Others leader receive the message and re-execute the change master command to new master instance. After the abort pod restart, the leader component received the event and execute the change master command to the new master. I prepared a demo video on my lab in advance. So let me show you. This is my lab environment that has a Kubernetes clusters. I create the MySQL cluster CRD name instead. You can see I create the MariaDB clusters. You can get the YAML file, the spec, the image, the spec we defined, like the LPS quota, the database resource, the CPU and the memory resource, and the master HA replicas number. And get the stateful set. The MariaDB cluster controller created 2 stateful sets, right? And the stateful set, the YAML defines the replicas number, the environment, the resource we allocated, and the PV where to mount the directory. So the 2 stateful set creates the each pause. We execute the pause, the bash, and see that the MySQL container, the leader container, they are into a pod. They show the namespace. And I want to show you the labels tagged to the pod. There has a key label. We label the DB role and label the pod is master true or false. And right now I killed a pod, the 010. We can show the its master label is go away, right? The pod is in its state. And then we can hold a second. We can see another pod, another MariaDB HL pod. The label is the field is master equal true. And we labeled the is master equal true as related to the service, the headless service. Then we go to get the pod status. And right now we execute the master role pod. Going to the bash. Okay. And we'll go to the MariaDB and show the status. That is the master state. That is the master status. And right now we get the pod status to see another pod. Okay, it's start up right now. We go into the MariaDB pod. When they show the slave status, okay, it becomes a slave and change master to the master now and use through the service. Okay. Okay, let's go on. The Kubernetes, the backup MariaDB instance, the Kubernetes job can start a pod to do one's task. The backup pod container designed to run in Kubernetes as a cron job to perform actual backup of MariaDB to the S3 cloud storage. The recovering a MariaDB instance, we need copy a backup file from outside to a new pod. We can use the init container feature to initialize the MariaDB instance. Before the new pod starts, we copy the backup file from S3 storage to the new pod with the mount PV, and running extra backup program reload the backup files to recover historical state. And there has so many articles introduce how to implementation, monitor system. We do not talk too much, while the logs are about a specific event. Metrics are measurable as a measurement at a point in time for a system. On Kubernetes, Prometheus is called native applications. Existing exporters allow bridging of third-party data into the Prometheus. The EFK is very easy to integrate into Kubernetes and supply log elections, analyzations, and exhibitions. The Helm. Helm is a third-party tool to deploy apps in Kubernetes, and Helm as like a apt-get or YARN under Kubernetes. It manages a complex collection of applications because our applications usually consist of multi microservices. Helm is very easy to upgrade or roll back the previous version if upgrade failed. Okay, thanks for your guys listening. If you have any further questions needed to be discussed, please feel free to email me or at my WeChat account. Many thanks.
Now for a look forward by Sergey Golubchik from the MariaDB Corporation, 10.5 and beyond.
Hello, welcome to the presentation about 10.5 and what's coming next. Let me introduce myself. My name is Sergey Golubchik and I was adding features to MySQL since 1998, and since 2010 I'm working on MariaDB. Now I'm a VP Server Engineer in MariaDB Corporation and a board member of MariaDB Foundation. So 10.5, main facts about it. We started working on 10.5 in May 2019, and in about a year we released a first J release, and as usual it will be supported for 5 years, so it will reach end of life in July 2025. In my opinion, the largest 10.5 feature is column store, so let's talk about column store. Column store is a storage engine for analytical queries. Imagine an analyst sitting in his laptop and cutting and slicing the data in various ways and grouping them and joining and ordering and stuff like that. This usually means static, mostly read-only data. This means complex select queries. And that means that you don't really know in advance what the analyst will do. So you cannot actually pre-create indexes in advance to optimize for his queries. And this is exactly the use case for column store. A bit of a history. Column store is not a new engine that we just quickly whipped up last year. It was under the name InfiniDB. It was developed by Calpon since 2000 to 2014, according to Wikipedia. And under the name column store, it was developed further by MariaDB Corporation since 2016. And now it had reached a step where it could actually be added as a pluggable storage engine into MariaDB Server. A word of caution, because in MariaDB, plugins can have independent maturity levels. MariaDB 10.5 is GA, it's stable, but column store is at the moment only Gamma, but it's still quite usable and hopefully it'll be GA quickly. So what is column store? As you might have guessed, is a column storage engine. That means that values for all columns are stored together. All values for one column are stored together, as opposite to, for example, in a DB where all values for one row are stored together. This works very well for analytical workloads where the tables are often denormalized with hundreds of columns, but you only want to look at a few of them. If you store separate columns separately, then you only need to read the data for those columns that you're interested in, significantly reducing the I/O and making the queries faster. Also, storing all values for one column together makes compression a bit easier. So 10 times compression in column store world is not something unheard of, it's typical. And also, column store has some kind of indexes or index-like structure for those columns. You don't need to create indexes explicitly. In fact, column store doesn't even support explicitly created indexes. It kind of automatically indexes everything all the time, which is exactly what you need for analytical use case, because you cannot pre-create indexes in advance, as I just said. So column store fits this one very well. You can modify your data with insert, update, delete, but as it's again usual for analytical databases, column store has a fast bulk data loader, which allows you to quickly load a huge amount of data into column store by passing a SQL interface directly into column store. And as it's not very usual for analytical databases, or was not, column store can easily scale horizontally. If you have lots of data, more data than your workstation can handle, you can add another storage node and then yet another storage node, and then you have a storage cluster of nodes that your MariaDB server will be talking to. Also, you can add another MariaDB and yet another MariaDB, many MariaDB nodes talking to the cluster of storage nodes, so you can scale both on the MariaDB level and on the storage level. Column store is a really huge thing, and it deserves a talk on its own, and deserves many talks on its own, and we don't have time for that. So this is the URL to the knowledge base. Read the manual if you want to know more about column store. Another new storage engine in 10.5 is the S3 storage engine. it's designed for inexpensive, reliable storage of archival data. Like imagine you have some financial transactions, or I don't know, some visits to your websites, user clicks, ads, advertisements that you show, and you store your current data locally in your data center, and then you also need to provide high availability, redundancy, and stuff like that. And data for previous months you can upload into the cloud, into Amazon S3, for example, and then you'll have rather inexpensive and quite reliable storage of your archival data, and you can work with your infrastructure on your actual data that you modify all the time. So, as again I've just said, S3 storage engine stores data in Amazon S3. It can also use any other compatible storage that uses S3 compatible API. The data in the S3 engine are read-only, so after you upload the data into S3 you cannot change them anymore, but which is fine because those are historical data that do not change. And S3 allows shared access to the data. You can have many MariaDB servers accessing the same set of S3 buckets, so you don't need to duplicate the data if you want to access them from multiple places. Again, there's a knowledge base page about S3 storage engine. There's also a Percona blog about it. You can check both if you're interested. Now, what new SQL features were added in 10.5, well, on SQL layer? I'll start with small and simple features, and then I work my way to the more complex ones and that I explain on following slides. First, our database can now have comments. It was a contributed feature. There was a pull request. It's not something we developed internally. You can create and alter database with a comment clause, or you can use show create database to see the comment. All the table can now rename columns and indexes. This also should be pretty easy, pretty clear. Select uses set operations like accept and intersect since 10.3, and now they can also support the all qualify, not only distinct. This is SQL standard feature, and it was developed again not internally but during the 2019 Google Summer of Code project. Google Summer of Code student implemented it for us. Another 2019 Google Summer of Code project was insert returning. With returning clause, you can return a result set from insert that contains the data you have just inserted. It's particularly useful if you insert lots of rows and you want to know generated auto increment values. You just add returning and the auto increment column name, and whatever auto increment values were generated, you can have them as a result set from your insert. If you use recursive CTEs to traverse graphs, you definitely have faced the cycle avoidance problem. Now it can be solved more robust and faster with the cycle clause. And if you use application time period tables, we now support with overlap standard constraint. And more about it on following slides. So cycle. This is an old example of the recursive CTE from our recursive CTE knowledge base page. If you want to see the complete example, go to the knowledge base, but it basically has a table of the US city names and another table of bus routes between those cities. And this recursive CTE shows all the routes starts from New York. So first select New York, and the second one recursively appends the current city to the current path, and locate condition. It rejects cities that are already present in the path to avoid cycles. So there are a few problems with this approach. First, as you can see, after finding a perfectly valid route from New York to Boston, it also suggests to go from New York to Boston via Washington, which nobody really does. It's 3 times as long, and so it's kind of a useless path that we don't really want to see here. But this is a minor annoyance. The major problem is there's a bug here in locate. Let's say we also had, besides New York, Washington, and Boston, we also had Marina Valley, California, and Reno, Nevada. This locate thing would find substring Reno inside the city name Marina Valley. It would think that the bus has already been to Nevada, even though it hasn't. So this is just plain bug, and this is the old version of this recursive CTE from the knowledge base. in the latest version I fixed this bug, but there is no completely foolproof way to fix these string searches. They are inherently buggy, inherently problematic, and also they're slow, particularly if you have long paths that do the string searches all the time. This is just slow. This is what 10.5 fixes. See, this is this query rewritten. It removes locate completely and uses cycle clause. So it doesn't invent any more creative ways to go from New York to Boston via Washington. Doesn't show this long path after it has found the short path, and also it's faster and it's bug proof as compared to the string searches. Now, as for without overlaps, let me first describe the use case here. Imagine this hotel booking system. So that's a table, it has hotel rooms, it has guest names, his check-in and check-out dates. And then we insert some data here. Alice moves in, checks into room 11 in October 1st and checks out on October 3rd. Then Bob will take room 12 from October 2nd to October 5th. And then Carol will take the room 11 after Alice checks out from October 3rd to October 7th. And then Dave will check room 12 from October 4th to October 6th. And now if you following the dates, you would have noticed that there's a mistake here because Dave cannot check in into room 12 because Bob didn't check out yet by October 4th. And with 10.5 we can make the database to check this constraint for us. First we need to declare this table an application time period table by creating a period of those dates. This way we tell the database that those two dates they considered a time period. This was possible in 10.4. In 10.5 we can add a new constraint. It's a unique constraint for room numbers and a period without overlap. That means that either periods should be without overlaps or room numbers should be unique. If two rows have overlapping periods, then those rows should have different room numbers, which is exactly what we need here. And if you would try to do those inserts into this table, you would get a duplicate key constraint, duplicate key error, which is basically exactly what we need here, because Dave can check out in the room that Bob didn't vacate yet. Now, one of the most user-visible changes in 10.5 was the splitting of super privilege. Super is a quite historical privilege that existed for maybe 20 years. Over time, it accumulated all the different commands and activities that didn't quite fit in any other privilege. So it became a security nightmare because you cannot grant anybody fine-grained access to do something. You have to grant the whole super that allows the user to do lots of kind of things. So we finally decided to bite the bullet and split the super into logically grouped activities, and every activity got assigned a separate privilege. For example, binlog monitor allows you to do show commands related to binlog, like show binlog status, show binary logs, show binlog events. And set user allows to change definer of stored routines and views. And I'm not going to describe every single one of them because, again, you can just check the knowledge base here. There were features that we have added to add more visibility into what MariaDB is doing, what's happening internally. And one of those features that was requested for quite a while is better performance schema support. More MySQL compatibility in the area of performance schema. We have added a lot of new performance schema tables to 10.5, making it basically MySQL compatible here. So if you have an application, some kind of monitoring application needs performance schema, it'll probably work with MariaDB out of the box. There are a few tables that we don't support yet, and we are working on supporting them. I'm not going to talk more about performance schema because there will be Valery Kravchuk's talk about performance, and he'll talk about performance schema in MariaDB. Also, we've added more tables to performance schema through information schema, providing more visibility into what thread pool is doing, and more status variables that describe various aspects of InnoDB, like memory consumption, net logs, again, exactly for this very reason, to provide more visibility into what InnoDB is doing internally. So now from performance schema, let's segue into performance improvements. Those are important performance improvements on the SQL server level. So until 10.5, you would do an order by, I don't know, varchar 300, then every sort key would take 300 bytes in memory, and if you use UTF-8, it would be 900 bytes. And starting from 10.5, sort keys would only take as many bytes as the actual value takes, which means that usually MariaDB would put a lot more keys into one sort buffer it would need to write much less data to disk, so the queries will be faster. How much faster, that actually depends very much on your application. In our benchmark, we have seen queries getting 5 times faster and 10 times faster and 10% faster, or not faster at all. It depends on the data type you're using, you're ordering by, on the character set. As I said, UTF-8 will get better speed improvements. It depends on number of rows on the table. It depends on how actually long your string values are. And also depends on what you're doing, what your query is doing, because if you do select star from a very huge table, then most of the time the server will spend sending data to the client, and any file sort optimization just won't be noticeable on that time. Another optimization affects everybody who needs to return numbers from the database, which I think is just pretty much everyone. In our simple select number from T1, we've seen 11% speed up by optimizing, removing unnecessary character set conversions for numbers. Now we've replaced PCRE, regular expression library, with PCRE2, and if you check regex engine machine speed benchmark, if you go for that, you'll see that PCRE2 could be sometimes slower. When both PCRE and PCRE2 are fast, then PCRE2 can be a bit slow, but usually it's faster. Sometimes can be 7 times faster if you do lots of OR operators. Depends on your regular expression. And by the way, note that all those improvements, they affect both single thread performance and multi-thread performance. It's what happens quite often, that if you want to improve high concurrency multi-threaded benchmarks like sysbench, then single thread performance, it basically goes down the drain. This is not the case here. All those improvements, they both improve single thread and multi-thread performance. And also parallel replication now is optimistic by default. It means the slave will try to parallelize as many transactions as possible, not following any more master concurrency. The slave will have a much easier time to keep up, even under load. So these were performance improvements on the SQL layer. There were also lots of improvements on the InnoDB layer, and I'm not actually going to explain them all. I just listed some of them, because there will be another talk by Marko Makela who will talk about scalability improvements in InnoDB, and then he'll be talking about all those InnoDB improvements. So just watch his presentation if you're interested. Now, there are a few features that don't quite fit in any of the previous slides, so I'll just list them here. All the binaries were named to use a consistent naming pattern, MariaDB-something, like MySQL dump was renamed to MariaDB-dump, and MySQL_upgrade was renamed to MariaDB-upgrade. But there are symlinks to all names, so all the scripts and all applications will continue work as before. You don't need to change anything. But the plan is in the future to make those symlinks optional. So this is interoperability feature. If you don't want to install the symlinks in future MariaDB version, then you will be able to install MariaDB and MySQL in parallel if you would ever need to. We've added a new data type called INET6, which stores, not surprisingly, IPv6 IP addresses. Note that it doesn't just store them in strings, it stores them as 128-bit byte numbers. So the first 0 that I've inserted, it's stripped, and the number is printed in the IP address is printed in the canonical form. You can also see actual bit value, numeric value of the IP address, IPv6 address if you want to. But what's actually important here is that we didn't just add a new data type, we added a new plugin type, a new infrastructure for pluggable data types. So now it's much easier to add new data types, and you'll see more pluggable data types added in the future. You can add yourself more data type plugins if you need to in your application. If anybody still downloads binary targals, you'd appreciate that they become much smaller. And if you're using system versioning and you care about performance, then you probably partition by system time to keep history separately from the current data. And typical partitioned table look like it has one current partition and one history partition. Because this is such a typical use case, we simplified it, and you no longer need to specify partitions explicitly. The MariaDB server will do it for you. You just need to specify tables partition by system time. If you want to have more than one history partition, you can do that too by just specifying the number of partitions, which is particularly useful if you want to rotate history by time, for example, like in this table structure, where every month of history is stored in a separate partition. There are other features, but we are running out of time, so I'm moving to the beyond part of my talk, beyond 10.5. And beyond 10.5 is, next release version is 10.6, so let's have a look. 10.6 facts. The 10.6 development branch was created in May 2020, but actually some of the features were in the development long before that for many months already. So it's not like we just only started working on 10.6 4 months ago. Now, I don't have a crystal ball, I don't know what will happen in the future, but if you look at other MariaDB releases, then they usually become GA somewhere in May, June, and they are usually supported for 5 years after that. So probably 10.5, 10.6 will be GA in May 2021, and it'll probably be supported until April 2026. But of course, I don't know. As usual, development happens all in public. So this is our Jira. You can search for yourself. You can search for fixed version equals 10.6 and see all the issues which were considered for 10.6. There are already, as you can see, almost 200 of them. So we definitely won't be able to do them all, and I'm not going to talk about them all. But this is my personal, highly subjective top 7 list of all those 197 features. The first one is, of course, the cross-engine alter table. This is something I wish we had quite a long time ago, and lots of users wanted it. It's when you alter a table and you can see it still continues to be writable until the alter operation finishes. And that's independently on what kind of alter you do. Even if you do it between different storage engines, you can still keep using the original table until the alter operation is done. Second one is atomic DDL. I don't quite need to explain that. I think atomic DDL is pretty clear, and it's a feature that you don't usually need. You only need it when you have a crash exactly during DDL, but when you do have a crash during DDL, then things can get pretty ugly. There could be data corruption if you are very unlucky. And with this MDEF implemented, then you cannot, because no matter when the crash happens during DDL, it cannot have data corruption or data loss. Keep sending metadata in binary protocol. It would be useful for anyone who's doing short selects, like point selects, and using a relatively modern connector that uses binary protocol. Because in this case, the metadata is sent twice, and it could be up to 3/4 of the actual data. So by skipping unnecessary metadata, we can send a lot less data over the network, and again, have the whole query round trip much faster. And another interesting feature would be adding support for JSON table. If you don't know, it's presenting JSON as a table, so you could do select from and then JSON. It's a SQL standard feature, and Oracle and MySQL both have them, and other databases. And users were requesting it. We are planning to have it in 10.6. Don't open partitions included by partition pruning means that if you have, you'll appreciate that if you have a table with lots and lots of partitions, maybe system version, I don't know, and you only need data from a few of them. Currently, MariaDB opens them all, but not open, I don't know, hundreds possibly of partitions that you won't be even looking at. You can shave a lot of time from the query execution. Executing DB crash recovery in background means that, if you have a crash and then after the crash, MariaDB will start faster. It'll be serving queries earlier, and it'll continue in a DB recovery in background. And the last one is, remember I just had a table structure with partition by system time, interval 1 month, 12 partitions. I get 12 partitions, and every new month of history would be going to the new partition. With this, when this feature would be implemented, I wouldn't even need to create 12 partitions, because every new month, Maria would automatically create new partition for the history. So it would make managing of partition system history tables much faster, much easier. But 10.6 is not only about new features. About half of the tasks are about refactoring. They are not generally user visible, but they improve code stability, they reduce number of bugs, improve maintainability, and quite often they improve performance too. I listed a few examples of those refactoring tasks from 10.6, but I'm not going to describe them. Talk to me on chat, write emails, check Jira if you're interested. So this is what we are working on in 10.6. But hey, you can participate too. You can suggest new features, for example, for us to do in 10.6. But yeah, you need to understand that there are already almost 200 issues and we won't be able to do all 200 anyway. So if you suggest a feature, it could just happen that it'll just fall below the priority level and just won't quite make the text, won't quite make the 10.6 deadline. Or perhaps your feature will be so awesome that we will decide to do it, absolutely do it at the expense of some other feature, then we remove some other feature from the 10.6 plan and we add your feature instead. So you can request a feature and you will see on Jira and you will see what will happen. Perhaps there's a feature that you definitely want to have implemented, and we decided that it doesn't quite make the line. You can just go and implement it yourself and create a pull request. As you have seen on previous slides, we accept pull requests, and if it's good, it'll be in 10.6. If you just want to get your hands dirty and help us and implement something in MariaDB, but you don't have a personal itch to scratch, look for beginner-friendly label in Jira. It marks tasks that one can implement without prior experience in MariaDB source code, so even junior developers can usually do them. So talk to us. You can talk to us on Zulip, you can write a mail to Maria developers list. We are always ready to help.
Now for Sanya Alexander Bielkin. How to get your bug fixed fast.
Hello, my name is Alexander Bielkin, also known as Sanya. I am working in MariaDB Corporation as a developer. Today I want to tell you how to make your bug fixed faster. So, what can you do about your bugs? Of course, you can do nothing. Eventually, it will be fixed, but it takes a lot of time probably, especially if it's code not so many people are using. So, what is better? Better you have to invest something. For example, simplest way probably for somebody is money. You pay for support. Support help you to prepare a test case for the bug. Also, support bugs are have high priority. But there are other ways. You prepare excellent test case and bug report, and then developers do not spend a lot of time on trying to figure out what to do and just start fixing it because problem is visible. Also, consciously or subconsciously, developers prefer some well-defined bugs with clear test case. Or you can do even both to make good test case and to pay for support and so get some high priority. But what developers want from you? Developers want the only thing, how to reproduce the bug. Another word, test case. So what could help reproduce the bug? The query. The query which caused the problem. It could be just query script, which has several queries or some step-by-step instruction which query to execute. Also database, like database dump or with all these tables, functions, and other structures related to the query. Also, it will be better if you, in clear words, describe what you wanted and what you got. So what's the problem? Also, it could be stack trace if it crashed. For some bugs, probably for most bugs, server version also important. We have not so many server versions, but you probably know what server you run. If it's really difficult to find exact version, just major number is enough, like 10.5 or 10.1 or whatever. Server configuration. Sometimes if you have some not usual server configuration, it's important. Or even if you have usual, but sometimes it depends on server configuration. But okay, if it's really difficult to get all configuration, maybe it's not, you can spend time on. Operating system, there are bugs which depend on operating system. Not so many. Environment variables, so it's really rare that they help. So, the query. Where to get the query? Of course, it could be that you just know the query because you are writing your application, or maybe you just issue queries, handmade queries to the server. And it's rare case, but easiest. If no, then you probably could check your logs. Or first of all, you have to switch logging on. So general query log has impact on performance. So just don't do it like for all the time and just in hope to get something. So switch it on temporarily. It will be even better if it's not production database and you can just repeat the problem on your toy database. Also, you have to know that if there are many connections to the server, your query, like query which caused the problem, could be not the last query. It will be the last query in that connection which caused the problem. But there will be a lot of other queries around. So if you gave us your query log, it's better to get several lines, not the last, and maybe all if it's not security important. Also, if server crashes, crash report procedure, try to write query to the error log. Sometimes it's impossible, sometimes it's do not get the query, but still maybe you have query in the error log. It's worth to check. How to solve what problem actually have sending us database? Database could contain confidential data or some private data, and also pay attention that whatever you attach to bug report in our Jira, it will be public. So if it's not information you want to see to everybody, you better upload it on Foundation FTP. There is an article in MariaDB knowledge base how to do so. And the other problem with database is size. There are some really huge databases, and it's not comfortable to send all of them. Okay, so of course we are happy to accept any size of database and any contents. We promise do not use it except just reproducing the problem, but still better be safe than sorry. So how to solve this problem? The easiest, simplest way, but not the most useful variant, is just to give us schema only schema or without data. So it's definition of tables, definition of procedures, definition of triggers and other stuff, but no data. Even in this case, it's better say something about data distribution, just because you probably know how data distributed. If you have more time, you could spend time on filling the database with some random or generated data and reproduce problem on the database. If you do not want us to see real table names or real field names or procedures names, after reproducing, you can just in, for example, in text dump of the database, change it on T1, T2 or something like this. But it's better after this check that problem is reproducible on this database. So what mistakes I saw? Of course, it's maybe some biggest mistake was filtered before I saw them. But still, many people trying to prove that there are some bugs. We really believe that there are some bugs. But it's not what important to us. It's important how to reproduce the bug. So don't spend a lot of time proving that there is some bug there. Just spend a bit more time on finding the way to reproduce it. Also, sometimes we get like very detailed description of operating system, of all setup of the server. but if it's usual standard configuration, usually it's not what we want. We want something reproducible. Sometimes we got only stack trace and nothing more. Okay, there are some bugs which could be solved by stack trace, but it's very, very unlikely. So even if you have only stack trace, it's also better to allow core dump and send us core dump with your binaries. Or maybe even with some libraries if it's needed. Because core dump can be viewed with debugger, and sometimes we could find something there. But to have good stack trace, one should install additional packages in the system, packages with debugging symbols, because otherwise even stack trace will be useless completely. So it's about this. So now let's try to make a bug report. To make a bug report, you have to be registered on Jira MariaDB org. So here in the top there is create button. Great. You got form to fill. So first of all, projects. It's important to correctly say what project has a bug. So let it be server. Then issue type, it's bug. Okay. Summary. Just put summary like you think it is. So let it be some function produce wrong result. Priority. Priority, it's okay, leave it as is. But if you feel that it's very important to you, you of course could put it like critical or even blocker. The problem is that the same field also used for our internal priorities. So after this, when bug will go in procession, like we will just do something, we will set there our own priorities. But still you can state how important it is for you here. Components. Components, it's something really difficult to define sometimes even for developer until its bug nature will be found and fixed. So just leave it as is. If you're not sure, it's okay. Affected version. Here, if you know, you can just put version, like, for example, full version. Or if you're, okay, no, only general version, you can just do it also, for example, like this. Environment. As I told, don't spend a lot of time here, but okay, you can just put here Linux, for example, or Ubuntu. It's okay. Description. Here it's better put some description and better formatted nice. So let's write it. So, as you can see, I put here some formatting things. Of course, query itself better cut and paste than write it just to have no mistakes, types, typo in it or something else. Also, so what else? Okay, here I wrote that it's attached database. You can just attach here as a file or just put it on FTP. Then you have to write here that you put it on FTP, file name and other stuff. So let's create it. It will take some time. So here is our issue. And also it was spend some time, read the bug just to check that there are no mistakes or errors in it. So just look through what we have here. Some function on the uploaded away. If you need, you can just click and you got form to edit. Then, okay, also with other fields as well as it could be edit like the same form which you saw before, or almost the same. So it's okay, your bug created. So what then? Then as soon as you have some changes here in the bug reported, you will get email. What to have pay attention to? Comments. Here you can just add your comments, by the way. Also some other people will put here comments. It could be communication between developers and support or between developers. Also it could be internal notes of developers, but also it could be question to you. Maybe something to define or something else. So just pay attention to comments, check if it's something asked. Also there is a label field. Here could be label need feedback. It's clearly shows that developer or support or whatever who now processes the bug needs some information from you. So it will be better to answer. So that's what you have to know about bug creation and then answering question and other stuff. So here I put in the presentation all this just as notes, just because probably the presentation will be available on the web. So here's description of the fields I already presented to you. There are many other fields there, but they're mostly used for technical things by developers or support or other people. So it's about communication. And what if you still have time and inspiration to improve the bug reports? The clear way to improve the bug report is just reduce test case. But remember, before any improvement, just save what you already have, just to do not just lose it. So what you can reduce? You can reduce database. Just remove tables which are not used by the query. You can just remove fields maybe from the table which are not used or indexes. How to check if index is used? You can just check explain, for example. But in any case, if you remove something, check again if bug reproducible. So if no, just revert your changes. Also, you can simplify your query, because we could have like really big queries. So what you can, so especially if you have some suspicious part of the query, which is unusual or only in this query, or by some other reasons you think that this part causes problems. So just try to remove tables, maybe remove some clauses like while or from, or not from is impossible, like having or row by or whatever. So maybe they're not needed, or some queries, some functions maybe are also not needed here just to reproduce the problem. So this is not mandatory or but just can help later, because in any case this work will be done by somebody before bug fixing or during bug fixing. So that's all. I hope after that you will report really nice, tight bug reports. Thank you.
So that was it for today's MariaDB Server Fest 2020. I'd like to say see you again tomorrow at the same time in the same channel, but it won't be the same channel. Stay tuned at mariadb.org/fest2020 and you'll see the channel to attend tomorrow. See you then!